Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in the bridge course. We have started to decide where we have decided to start that where we'll be helping you with these sessions which are quite essential from your foundation years, that is from 11th standard. But if you might have missed those, which means if you haven't developed the right knack or the right aptitude of these chapters, will be helping you in the beginning of your 12th. So right before the beginning of your 12th, we are helping you with certain chapters which will work as a bridging. Bridging means these chapters are those chapters which are quite essential for your 12th standard as well, where you have dual pressure. The dual pressure means the pressure of the boards and of course the competitive exams which you are going to target or appear for in this year. So once again, hello, hi, namaskar everyone. Just give me a quick update in the comment box. Can you all hear me and listen to me properly? And with that, let us get started with the discussion from this session. So majorly from mathematics, we'll be conducting 4 such sessions. First will be on this essential, the basics of mathematics, where we'll be covering all sorts of learnings which you might have learned or understood so far till 11th standard only. But if you have missed any of those nuances or basics or those minute details, we'll be covering here in this video. Then afterwards, 3 more sessions are yet to come, which will be revealing very soon. Great. So good to have you, Ayush, Anjali, Hari, Rajan, everyone. Good to have you all. And without any delay, let's get started. Here, first of all, let me try and tell you what all we are will be covering. First of all, yes, we all know what is the importance of intervals. So sometimes you get confused with the kind of intervals you are going to deal with them. We'll be covering that. And then we'll talk about inequalities in a very detailed format, because in JEE Mains and Advanced, they ask you a lot of questions from inequalities. Directly, indirectly, or subtly, questions are there based on inequalities. So we'll be solving those questions as well and understanding the basics that inequalities are different from equalities. And then we'll talk very quickly about divisibility, because in probability or in permutation and combination or in some other chapters as well, you deal with questions from divisibility, for example, binomial theorem as well. And then we'll talk about some polynomials, related to which we'll talk about remainder theorem, factor theorems. And then yes, when you study the chapter quadratic equations, the chapter theory of equations, there you study a lot of identities. These identities are not just useful in that chapter only, but they are used in your entire mathematics. So we'll be discussing those identities as well. Good to have you, Star Play. And then of course, something which is very widely misunderstood by a lot of students and on which JEE loves asking questions, which is root gain and root loss, where students commit a lot of errors. That part also will be discussing. And then of course, inequality is not just limited to simple linear inequalities. You got to deal with inequality based questions where you are squaring or taking the modulus or removing the modulus or taking the square root, or you are dealing with reciprocals. That also will explore. And here will come up with something very interesting, which is called wavy curve method. Of course, you must be aware of it is not baby curve method. It is of course wavy curve method, which is also will be discussing. So good to have you everybody. Ayush, Advait, Trisha, everyone. Hello, hi, namaskar, everyone. So with that, apart from this, we'll be discussing a lot more. But if I quickly tell you what we'll be discussing here, then let's get started and let's learn all of these basics. I hope you know what are numbers. Natural numbers, the set of numbers which begins with 1. So the purpose of counting gets fulfilled with the natural numbers. Let's say I have 1 pen, 4 fingers in this hand with 1 thumb. So natural numbers are used for this purpose. The set of natural numbers in the world of mathematics is denoted by capital N. With that, when you talk about whole numbers, so 0 is also appended to that set, and the set of whole numbers is denoted by capital W. I hope everybody is listening and understanding. Trisha, I'm bound to speak in English because this is PW English medium. So here we are supposed to speak in pure English, in full-fledged English. Now, when I continue further, we talk about integers as well. So you have natural numbers, you have whole numbers. When these natural numbers are attached with negative signs, so you get integers as well. So the set of natural numbers, when clubbed with negative natural numbers, let's say for a while for our understanding, then these become integers. And here, remember, set of integers is either represented by capital I or capital Z. I hope you'll remember that. Any confusions on that? You need not apologize for that, Trisha. It's just a request which you made, and I simply said the constraint here. Now, we need to understand that in JEE Mains, they ask you a lot of questions by manipulating the language. Now, how do they play with the language? Sometimes they say that all the positive integers, So I hope you're understanding when you talk about all the positive integers. So we know 0 is neither negative nor positive. So if I'm talking about all the positive integers, which means what? I'm talking about all these numbers. So if somebody says all the positive numbers, so directly or indirectly, what are they mentioning? Are they not mentioning all the natural numbers? So whenever somebody says that natural numbers are to be considered in a question, then they are trying to say the positive integers and vice versa. And yes, positive integer set is denoted by I plus or z plus. Now when I move ahead with that, set of whole numbers is also called as set of non-negative integers. Now what is non-negative? The set which does not contain negative ones. So 0 is neither positive nor negative, which means in this set I'll not be having the negative ones, but I'll be having the non-negative ones, which means it will begin with 0, 1, 2 and it will go on like this, which means what? This is the set of non-negative integers. So non-negative does not mean positive. Are you listening and understanding? There are three worlds: the world of negative numbers, the world of 0 and the world of positive numbers. So when I say non-negative numbers, which means 0 and the positive ones. Are you listening and understanding this language, students? Now with that, the third part, the set of negative integers is denoted by I minus, and here the set of non-positive integers is of course minus infinity to 0. I hope so far no confusion is there. You all know these basics. You all must be aware of these nuances. Now here, when we go ahead, few basic or few more minute details, we all know that one is neither prime nor composite. Why? Because if I wish to call a number to be a prime number, then this number should be having exactly two distinct roots, exactly and only two factors, not roots, which means what? If I'm talking about 7, so 7 is divisible by two numbers, 1 and 7, which means it has two distinct roots and exactly and only two distinct factors. I'm sorry, not roots, factors, which means 7 is divisible by exactly and only two numbers. In that case, we call it prime. But if when you look at 1, 1 is divisible by 1 only. That means 1 does not fulfill the criteria to be called a prime number. So remember, 1 is not a prime number. I hope most of you are already aware of it. But when you talk about composite numbers, which means the numbers which have more than two factors. For example, if I talk about 24, so 24 is divisible by 1, it is divisible by 2, 3, 4, 6, 8, 12, and of course 24. So it has more than two factors, which means this is a composite number. Everybody with me on this? I hope you know that 2 is the only even prime number. We all know this basics. So when I go ahead with this, remember, this is something very interesting. All the prime numbers, I repeat, all the prime numbers, I repeat, all the prime numbers except for 2 and 3, except for 2 and 3 are of the category 6n plus minus 1. Did you listen to what I have just said? It means if you ever see a prime number except for 2 and 3, it will always be of the category 6n plus minus 1, which means if there is a prime number, just forget 2 and 3. Apart from them, any prime number you take, it will always be one more than a multiple of 6 or one less than a multiple of 6. Are you listening and understanding? What I have not said is, I am not saying that all the numbers of this category will be prime. No, I did not say so. What I'm saying is, if any prime number is there, except for 2 and 3 of course, then it will fall under the category 6n plus minus 1. I hope you can understand this by simply taking this example. When I take certain prime numbers, what does it mean? Let's say after 3 we have 5, then 7. So 6 into 1 is 6, minus 1 is 5, 6 into 1 is 6, plus 1 is 7. I hope you understand. 6 into 2, 12, 12 minus 1 is 11, 6 into 2, 12 plus 1 is 13, 6 into 3, 18, 18 minus 1 is 17, 6 into 3, 18, plus 1 is 19. But I am not saying this that all these numbers of 6n plus minus 1 category will be prime. But if there is a prime number, it will be of this category. Isn't it interesting? Something very interesting about prime numbers. I hope most of you were aware of it. Similarly, this list goes on, but I hope you're understanding. 6 into 4, 24. 24 minus 1 is 23, but 24 plus 1 is 25. So I hope you're able to digest and understand my statement that all the numbers of 6n plus minus 1 are not prime, but if there is a prime number, it will be of this category except for 2 and 3. Everybody got that idea? Great. Now from there, something very interesting you got to develop here is this, that how do we verify or validate that there is a prime number? Let's say I wish to verify that 141 is prime or not. I wish to check whether 141 is prime or not. How do I validate this? A very interesting fact is there. All you need to do is take the square root of 144, or rather try to look for a perfect square which is just small than 141 or equal to 141. I hope you're listening. So here, when I talk about 141, a square which is just equal or smaller than 141 will be 121. I hope you're understanding. That is the square of 11, because with the 12, it will be 144. So the number which is either just equal to or smaller than 141 is 121. Now look at this 121. Can you help me with the square root of 121? Sir, we all know that is 11. Is 11 a prime? Great. Now talk about all the prime numbers which are less than 11. So that will be 7, 5, and then of course 3, and then 2. Now just check whether this 144, 141 is divisible by any of these or not. If this 141 is divisible by any of these, then I'll say it is not prime. But if this 141 is not divisible by any of these, I will unhesitatingly call it to be a prime number. Did you listen to my words very carefully, all the participants? So I hope you know how to check it by 11. For divisibility rule also, we'll have a different slides. I'll be covering them there. So with 11, I can clearly see it is not divisible. 7, it is not divisible. 5, no. But by 3, I think it is divisible. 4 plus 1 plus 1, that is 6. So by 3, it is divisible. And if it is divisible by 3, it is not a prime. I hope you got that. So it is going to be a composite number. Isn't it interesting? Within few seconds, you could figure out it prime or not, because this category of few nuances or short techniques, if you are aware of, you could crack a lot of questions very quickly. Because once, I think Abraham and Lincoln has said that if you have 6 hours to cut down a tree, you should spend the first 4 hours in sharpening the saw. So if your tools are sharpened, you'll be cutting the tree in a more efficient manner, in a more effective manner. That's exactly what we are trying to do here. If we are more sharpened with our tools, we'll be solving the questions more quickly. And that's exactly what we wish to do or need to do in the real examination hall. Great. Everybody just give me a quick response. Are you able to understand and digest whatever is being said? With that, can we move ahead from here? Now, whenever there is a number which is divisor or divisor of numbers n1 and n2, then this is a divisor or a divisor or of their sum and difference as well. This we'll discuss in a more detailed format when we discuss the binomial theorem. But remember, if a number can divide two numbers, then that number can divide the sum, difference, and product of those two numbers as well. Please remember that. That's a basic fact. Now here, if there is a number m, which we have already discussed, yes, this is something very crucial. On this, JEE has asked questions few times. So just remember this as a fact. Let's say there are two numbers. Let's say there are two numbers. For example, any two numbers you take. Any two numbers means, let's say I'm taking 6 and 8. Can you help me with the LCM and HCF of 6 and 8? So when you talk about LCM of 6 and 8, I hope you're understanding. LCM means the lowest common multiple, which means the number which is the smallest possible number, which is divisible by both 6 and 8. So when you look at 6, it is clearly 2 into 3. When you look at 8, it is 2 cube. So when you look at the LCM of 6 and 8, it is going to be 24. I hope you're understanding. So LCM of 6 and 8 is 24. What is the HCF of 6 and 8? HCF means highest common factor, which means the greatest possible number which can divide both 6 and 8. The greatest possible number which can divide both 6 and 8. What does it mean? I'm looking for the largest possible number which can divide both 6 and 8. I mean, it will be 2. So here, the LCM of 6 and 8 is 24. The HCF of 6 and 8 is 22, which means this product will be equal to the product of 6 and 8. That's exactly what I'm trying to say, that LCM and HCF of two numbers is always equal to the product of those two numbers. Will you remember that? This is true for two numbers only. Please remember that. So whenever you are given two numbers, their product will be equal to their LCM and their HCF. These are some basics. These are some nuances which, if you are aware of, you could be solving these questions or the questions asked by JEE very, very, very quickly. Can we get ahead with this conclusion? Now, let us talk about few more things. Two natural numbers, not necessarily prime, are co-prime. Now, what is the meaning of co-prime? There are questions asked on this word co-prime. Co-prime means if their HCF is 1. Did you listen to that part? For example, if there is a number, let's say 12 and 25. So 12 and 25 are not necessarily prime. I'm not saying that. But in this pair, if you look at 12 and 25, the highest common factor, the greatest common divisor of 12 and 25 is 1, which means 12 is divisible by what? 1, 2, 3, then 4, then 6, and then 12. When you talk about 25, 25 is divisible by 1, 5, and then of course 25. So when you look at the common divisors, except for 1, there is nothing common between their divisors, which means 12 and 25 are going to be co-prime. Did you all understand that part? Can I move ahead from here, all the participants? Are you all getting this conclusion very quickly that 12 and 25 are pairwise co-prime for each other? Because there is nothing common between them except for 1. That means there is no number mathematically which is greater than 1 which could be dividing both simultaneously. Which means if I could look, let's say for 6, 6 is dividing 12, but it is not dividing 25. So pairwise if two numbers are said to be or called to be co-prime, that means except for 1, no other number can divide both of them simultaneously. Just give me a quick update in the comment box. Did you all understand this part? That how do we define co-prime numbers? All the participants. From here, these are the examples of co-prime numbers. Now, when we talk about real numbers, so two distinct prime numbers are always co-prime, but converse is not true. We all understand this fact that if two prime numbers are there, then they'll always be co-prime. For example, if you take, let's say 7 and 25, since they are 7 and 25, so 7 is divisible by 1 and 7. 25 is divisible, sorry, it's not 25, I'm really sorry. Let's say 29. So 29 is divisible by 1 and 29. So of course, nothing will be common between them because they are prime. So 7 and 29 will be co-prime for each other, but it is not converse. Converse is not true. That means if two numbers are co-prime, then they'll be necessarily be prime. That is not true, as we have just discussed in the previous slide. 12 and 25. They were co-prime for each other, but they were not prime. They were not necessarily prime. Did you understand that statement, all the participants? Can I move ahead from here? Everybody with me on this? Remember something very interesting. Consecutive numbers are always co-prime. Can you believe that? How interesting that is as a fact. We are talking about numbers. We are wondering about numbers. Now imagine this. I take any two consecutive numbers. Let's say I take 32 and 33. Now when you take these two numbers, what about 32? So 32 is divisible by the powers of 2, which means 1, 2, 4. These numbers can divide 32. What about 33? So 33 is divisible by 3 and 11 only. I hope you are understanding. 32 is divisible by 1, then 2, then 4, then I think 8, and then 16 and 32. So I hope you can clearly see when you look at the divisors of 32 and 33, the common divisor between them is 1 only. Except for 1, there is no other number. Which means 32 and 33 are also going to be co-prime. Which means two consecutive numbers are always co-prime. Will you remember that as a fact? All the participants. Can I move ahead from here? Are you all understanding, listening, watching, and getting whatever I'm saying? Now with that, when I go ahead, yes, if natural numbers P1 and P2 are co-prime, and the natural number P is divisible by both P1 and P2, then P is divisible by the product P1 and P2 as well. What does it mean? Let's say if natural numbers P1 and P2 are co-prime, let's say I take two co-prime numbers, let's say 3 and 8 I have taken. So we know 3 and 8 are co-prime because there is nothing common between them. Are you all getting this? Now what I'm saying is that a natural number P is divisible by both P1 and P2. Let's say there is a number, let's call it 24, or rather let's call it 48. So I hope you can see that 48 is divisible by 3 because it is there in the table of 3. It is divisible by 8 because it is there in the table of 8. So remember this, if a number is divisible by 3 as well as 8, where these two numbers are pairwise co-prime, if these two numbers are pairwise co-prime, then this 48 will be divisible by their product as well. Did you understand that part, or shall I repeat this? Everybody with me on this? Why will it be true? That's good, Avinash. Thank you so much for that. I hope you are understanding this as a simple fact, because if they are co-prime, and if any number is divisible by them, then of course it will be divisible by their product as well. It is bound to be there. I hope both divisible by both P1 and P2, then P is divisible by the product P1, P2 as well. Everybody with me on this? Because it is bound to happen because they are co-prime. There is nothing common between them. So their product will definitely divide that. Everybody got that? Now from there, when I go ahead, yes, if the difference between two prime numbers is 2, then the numbers are called twin prime numbers. Why are we discussing these terminologies? Because in the examination hall, they'll not be saying or mentioning, yes, that's good, that's easy. They'll not be mentioning that, yes, these are twin prime numbers. They'll not be defining. You got to have this understanding, this basic understanding of your mathematics. So yes, if two numbers are there which are prime, let's say, for example, 5, 7, they are prime, and the difference between them is clearly 2. So if the difference between two prime numbers is 2, then they are said to be twin prime numbers. 6n plus 1, 6n minus 1. Do you remember that? Do you remember that? I hope you do. For example, 6 into 5 is 30. 30 minus 1 is what? 29. And 30 plus 1 is what? 31. So 6n minus 1, 6n plus 1. Twin prime. But I hope you remember, not all the numbers of the category 6n plus minus 1 are prime. But if there is a prime number, it will fall under the category of 6n plus minus 1. Do you remember that? Can we move ahead from here, all the participants? Now from here, when I go ahead, let's talk about real number system. Something really basic and easy. We all know that. So if you have integers, so from integers, what we know is, what we develop is rational numbers. I hope you remember rational numbers. What? Any number which can be represented in a p by q form, where we know that p and q both are integers, but we know one thing, that here q should never be 0. There comes one more constraint. If you want it to be a proper rational number, then you say that p and q should be co-prime, which means if I'm saying that here there is a number 12 by 24, then between 12 and 24, we can clearly see 2 is common. So I'll be simplifying it first, or rather 6 is common. So I'll be simplifying it first. So when it is simplified, it becomes 1 by 2. So of course, 12 by 24 is definitely a rational number, but being more specific, I'll take it as 1 by 2, mathematically speaking. I hope you understood that part. So you'll have rational numbers. But when you talk about irrational numbers, write the answer in the comment box. What do you think? Pi, is it a rational number or an irrational number? Just do tell me in the comment box. Pi, what will it be? A rational number or an irrational number? Give me a quick update on this. All the participants who are watching it right now, how do you treat pi as? Will it be a rational or an irrational number? If you think that pi is a rational number, then yes, some of you might convince me by saying that, sir, pi is 22 by 7. And 22 by 7 is a rational number because it is in the p by q form. But I hope you all know it very clearly. Pi is not exactly 22 by 7. This is the approximate value of it. This is the approximate value of pi. And when you talk about irrational numbers, what do they mean? Irrational number means that numbers are appearing 1, 4, 2, 8, 7, 3, 2, and so on and so on. The digits are coming up, and there is no pattern, there is no repetition. For example, you deal with, let's say, this kind of number 2.72. So this is what? A rational number. Why? Because it got terminated. After decimal, there was termination in it. Even this number, let's say I am writing 1.35, 35, 35, 35, and so on. So if there is even no termination, but if it is getting repeated, if there is a pattern, if there is a recurrence, then also it will be a rational number. So this is a rational number. This is also a rational number. I hope you do remember this sign represents belongs to, and this Q means the set of rational numbers. That's good, Avinash. That's brilliant. But I hope you all do remember that here, any number which is just giving me different digits, For example, E, the Napier's constant. It is clearly an irrational number because after decimal, you don't see anything. Yes. But Avinash, these basics, most of the students are not even aware of. These are such simple basics, but a lot of students are not aware of. That's the, what should I say? The kind of scene or scenario here we have. Then, of course, when you talk about pi, so 22 by 7 is indeed a rational number. When you talk about pi, it is clearly an irrational number because it never terminates and it neither nor repeats. So when you talk about rational and irrational numbers, and when you club them, when you club all the rational numbers and when you club all the irrational numbers, there you get the set of all the real numbers. So I hope you know, on the real number scale, you see numbers from minus infinity to infinity, and between them you see 0 to be there. And yes, of course, here we see the set of all the real numbers. Here, it can have all the rational numbers, it can have all the irrational numbers as well. Rational means it can have all the integers. Integers means it can have the whole numbers and natural numbers as well. I hope you got that part. Can we move ahead from here? All the participants, everybody with me on this. Now, I hope you must have studied complex numbers as well. Or if you haven't, then we talk about this part where we talk about the real numbers. There is another set where we talk about the set of complex numbers. So there is a concept of imaginary numbers. For example, if I were to solve this equation, x square plus 1 is equals to 0, I'll be solving it like this, that x square is equals to minus 1. So we say that x will be plus minus under root over minus 1. So Euler was a mathematician who suggested that let's assume for a while that under root over minus 1 is represented by iota. So there we say that x is equal to plus minus iota. He gave a hypothesis based on which a lot of discoveries were made from in the branch of mathematics. So that is something imaginary, but it gave a lot of good, decent results. So there we come up with few more conclusions that real numbers has even a superset. So you have set of real numbers, you will have a set of purely imaginary numbers like iota, 2 iota, 3 iota. And when real numbers are clubbed with imaginary numbers, you get the set of complex numbers. So complex numbers so far in our history, humankind's history, is said to be the superset of all the numbers. Yes, in the real world, the real number set is the superset, but above it, there is a complex number set as well. Because here, this is what? This is purely real numbers, and there is a set of purely imaginary numbers as well. And when these purely real and purely imaginary are clubbed, for example, 2 plus 3 iota or 5 minus 6 iota, then you get the complex numbers. Everybody getting that? So remember, all the real numbers are complex numbers. Because if I say there is a complex number, there is a real number 2. So can I not write 2 as 2 plus 0 iota? So it is a complex number. Are you all getting it? Everybody with me on this? I hope the number system is more understood by you now. Here, when we talk about this, as we have discussed, E and pi, they are the irrational numbers. We have talked a lot about real number system. Here, you got to remember something very interesting, that if I talk about, let's say if I talk about square root over, let's say, minus 3 square, then what will be your response? Can you tell me in the comment box? Students, all these students who are watching it, what will be the answer of square root over minus 3? Square root over square of minus 3. If you are thinking that, sir, here answer will be that this square root and this square sign be cancelled and the answer will be minus 3, then how many of you think or believe that it is right? Do tell me. I can understand, Avinash, but I cannot stop the ads. They come by themselves. We cannot do anything about that. But please listen to this part. What do you interpret by this? Is it true? Square root over square of minus 3. Will it be treated as minus 3? Can it be treated as minus 3? If you think so, in that case, I might want to interrupt and say that square root over square of minus 3. So what will be the square of minus 3? Sir, that's 9. So it will be square root over 9. And what is the square root of 9? Sir, that's 3. So in that case, what you have proved is that minus 3 is equal to 3. I think that's not true. That's false. So that is false. So I think I'm making a mistake somewhere. Where am I making the mistake? Am I making the mistake in this part or in this part? Do tell me. Now here, the basic which you all must have studied again in 9th and 10th standard only, that when you take the square root of square of a number, then you are supposed to put a modulus sign. What does it mean? It means square root over square of minus 3 will actually be modulus of minus 3, which means it should be 3, which means this is false. Are you understanding this, all the participants? So remember this, square root over x square is not x, it is mod x. And that is something you got to keep yourself, because it is used at a lot of places and a lot many times. That's good, Avinash. That's brilliant. So will you remember that? Everybody, all the participants, are you all there listening, watching and understanding? Can you help me with this then? I hope you all are there. Let's say if I were to ask you square root over 2 minus root 5 whole square, what will be the answer in this case? What will be the answer in this case, students? Do write in the comment box. I'm waiting for your responses. What will be the answer to this question? Square root over square of 2 minus root 5. If again, a lot of you say that, sir, square root nullifies the square sign and your answer is 2 minus root 5, then I think you got to cross check it again. You got to cross check it again. Why am I saying so? That's good. Why am I saying so? Because please pay attention. What we have just discussed is that, sir, square root over x square is mod x. So are you really sure that it is mod of that number, which means it is the absolute value, it is the absolute numerical value? Let me check it. 2 is 2, root 5 is 2.2 approximately. So 2 minus 2.2, I think that is negative. So out of square root, how can you have a negative term coming out of it? When you take the square root in the real world, the positive numbers comes out or the non-negative numbers comes out. But here, I am seeing a negative number coming out of it. Are you understanding it? So that's again wrong. What does it mean? When you are taking the square root over 2 minus root 5 whole square, then first of all, you're supposed to put a mod over it, which means 2 minus root 5. Now check it, whether it will be 2 minus root 5 or root 5 minus 2. So I hope you're understanding 2 minus root 5 is mathematically wrong. That's good, Avinash. You're taking the square root. Here, pay attention to that. 2 minus root 5. Pay attention to that. 2 minus root 5 or root 5 minus 2. So if I now go back to the definition of modulus of a number, we know mod x is either x or minus x. Sir, mod x is x as long as x is greater than equal to 0, and it is minus x if x is negative. So if I were to remove a mod from here, I hope you're understanding, x is 2 minus root 5, and here 2 minus root 5 is negative. So if 2 minus root 5 is negative, I'll be removing modulus with the negative sign, which means here it should be negative of 2 minus root 5, which means my answer will be root 5 minus 2, which is basic and understandable. You could have directly written this out of this. But always remember, don't be in a rush or in a hurry to cancel this square sign by this under root sign. Are you getting my statement? Don't be in a rush. Ensure that the number which you are finally writing, whether it is non-negative or not. Non-negative means it should be either 0 or greater than 0. That's good, Avinash. That's brilliant. I'm glad. And apart from Avinash, all the other participants who are watching it live, are you all getting it? Are you all understanding it? Everybody with me on this? Did you all understand this part? Can we move ahead from here? Then when I go ahead, yes, complex numbers we have already discussed. So you have natural numbers, then you have set of whole numbers. So set of natural numbers is a subset of whole numbers. Set of whole numbers is a subset of all the integers. Integers set is a subset of all the rational numbers. Then rational and irrational are clubbed. They give you the real numbers. So real number is a subset of complex numbers. So the superset or the universal set of all the numbers, now we know, is not the real number set, it is the complex numbers. Everybody got that? Everybody, all the participants. Now from here, when we go ahead, what do we see next? Yes, the interval theory. Now what does it mean? I'll try and explain it with some simple examples. Let's say on the real number scale, I have numbers which I'm taking, let's say, from minus 7 to 5, where I'm mentioning that minus 7 should be excluded and 5 should be included. So mathematically, how do we write it? So here, how am I defining that, sir, x is a number which is greater than minus 7, but it is less than equal to 5. So I'm supposed to include all the numbers between minus 7 to 5, but exclude minus 7 and include 5. I hope you remember. Mathematically, we'll be writing it as that x belongs to. I hope you do remember that this sign here represents belongs to. X belongs to which set? From minus 7 to 5. So I need to include all the numbers from minus 7 to 5. So we write them like this. Where I am including 5, so I'll use a parenthesis. Where I'm excluding minus 7, so I'll use an open bracket. So this open bracket is called open interval. This parenthesis is called closed interval. Which means if I take few more examples, I hope you are getting it more clearly. Let's say if this is the number scale where I'm taking the numbers from 11 to 30, 23, let's say, where 11 is included and 23 is excluded. How will you write it? I hope you understand that if x is needed to be defined, I'm taking all the numbers from 11 to 23, but 23 is excluded and 11 is included. Which means what? Which means these are all the numbers which will be there. So closed interval, open interval, I hope you are aware of this. If you have studied it in 11th standard, you must be very clearly aware of it. Can I move ahead from here? All the participants. So I hope you are aware of open interval, closed interval and all. Now, when we talk about union and intersection, how do we do that? I hope you know this part as well. When we talk about union and intersection, for example, there is a number which is from, let's say, minus 7 to 3. and there is a number which is from 0 to, let's say, 5. But it is from 0 to 5 in this manner. So this is the number which is from 0 to 5, and there is a number which is from, let's say, -7 to 3, like this. I hope you're understanding it. Everybody with me on this? So let's say this is a set A. This is your set A. So set A belongs to all the numbers from 0 to 5. So I hope you're understanding. 0 to 5 means on 0 I'll be having open interval, on 5 I'll be having closed interval. There is another set B, which belongs to all the numbers from -7 to 3, where -7 and 3 both are included. Now, two things I'm asking you. Do write your answer in the comment box. What will you say about A union B, and what will you say about A intersection B? Do tell me. What do you think of A union B, and what do you think of A intersection B? I hope everybody is clear with this. When you talk about intersection, that means the portion which is common to both of them. So do you not think that, sir, this portion here is the portion which is common to both of them? This is the portion where set A also exists and set B also exists. Do you all not agree with that? But what do you mean by A union B? First of all, let me write the set A intersection B. So set A intersection B means what? Here, 0 to 3. Now, A intersection B means 0 to 3, but which part is needed to be excluded and which part is needed to be included? I hope you are understanding. Sir, 0 is there in B, but it is not in A. It should be in both. Then only it is included. So 0 will be excluded. What about 3? So 3 is there in the set B, 3 is there in the set A, which means it needs to be included, which means I'll be using the parenthesis or the closed interval. Everybody got that? Now, when you talk about A union B, what does it mean? I hope everybody is getting it very clearly. A union means the portion where only A exists. A union B means the portion where only B exists. A union B means the portion where both A and B exist. So it means only A, it means only B, or it means A and B both. Mind you, the language which I'm using, only A, only B, A and B. So A and B means intersection. A and B means intersection, and A union B means or union, which means if I talk about A union B, it means only A, only B, or both, which means from -7 to 3 and then from 3 to 5, because 0 to 3 is both, which means my answer will be from -7 to 5. My answer will be from -7 to 5. But do tell me that will I be including 0 or not? Do tell me, will I be including 0 or not? I hope most of you must agree that says 0 is not there here, but it is here. So even if it is present in one of them, it should be included. So -7 to 5 I'll got to include. But what about -7 and 5? Will I be including them or not? Sir, -7 is there in set B, 5 is there in set A. So they are also to be included. So did you all get that? Did you all understand this? Everybody with me? I hope you are understanding how are we evaluating the union and intersection part with this interval theory. Everybody with me on this? Just give me a quick update in the comment box if you all are there listening and understanding. From here, when I go ahead, these are the basics which we have just discussed. Now, let's talk the basics or the nuances of inequalities. There, students make a lot of mistakes. First of all, understand we have been solving equations a lot lately, but we haven't dealt much with the inequalities. So with inequalities, there are certain different rules. What are those rules? Let me begin with that. If there is an inequality, then you can definitely add any real number to both these sides. It will not affect it. If you can add, means you can subtract as well. But do remember, if there is an inequality, then you cannot multiply it by any real number on both the sides abruptly. Which means, if you are willing to multiply both the sides by that number, you got to know that number. You got to know that number. What does it mean? It simply means, let's say if I'm told that 7 is greater than 3. 7 is greater than 3. That's good, Sumati. Now here, if I'm multiplying both these sides by 4, of course it will be 28 and it will be 12. And here it will be greater than 28 will be greater than 2. But if I'm multiplying it by -3, let's say y, so it will be -21, it will be -9, and I hope now you know it will be lesser. So when you multiply an equation, an inequality with a negative number, the sign changes. If you multiply an equation with a positive number, the sign remains same. So whenever you are doing that cross multiplication thing, first of all, with inequalities, you don't do that. So here, remember this, if you want to do that, you got to know that variable. So in inequalities, you cannot multiply both the sides by a variable, because variables can be either negative or positive or zero. I hope you're understanding it. So whenever you're solving an inequality, please avoid cross multiplication. Don't do that. Second, whenever you're solving an inequality, don't multiply both the sides by a variable, because variable can be positive or negative. If it is positive, the sign remains same. If it is negative, the sign changes. And if you are not aware of the variable, because it is variable, we are not aware of that number. So how will I decide the sign of that inequality? Everybody got this? Just give me a quick update in the comment box. From here, when I go ahead from here, something very interesting. Please remember that if three numbers are positive, let's say there are three numbers which are positive. Let's say 3, 7, and 9. And of course, we know this relation is there. So if I take their reciprocals, the sign changes. Not just about three numbers. Let's say there are two numbers. Of course, both of them should be positive. If both of them are positive and if I'm taking their reciprocals, the sign of the inequality changes. Will you remember that? I hope no confusion on that front. Everybody with me on this? Here, two inequalities can be added, which means, let's say if I'm told that A is less than B and C is less than D. I repeat, A is less than B and C is less than D. This is what I'm told. So if I'm adding these two inequalities, which means I'm adding A plus C and I'm adding B plus D. So the sign still remains same, which means sum of two smaller numbers will be less than sum of two greater numbers. It is bound to happen. Everybody getting this? I hope you'll remember that. Sir, can we subtract inequalities? No. Sir, can we add inequalities? Yes, but we cannot subtract the inequalities. Sir, if we want to, as per the question, if the need arises, how are we going to subtract inequalities? Can we do so? Yes, there is a catch here by which you can do so. What does it mean? Let's say I have A less than B and I want to comment on what will be the value of A minus D and C B minus C, let's say, for a while, or what will be the relation there. So we know C is less than D, that is what we are given. So if I multiply this inequality by negative sign on both these sides, so I hope you know when negative sign comes into picture, the sign changes. So it will be minus C greater than minus D. I hope you're understanding. Here I'm saying is that minus D will be less than minus C. So we are told A is less than B, minus D is less than minus C. Sir, can we add two inequalities? Yes. So sum of two smaller values, which is A minus D, will be less than sum of two greater values, which is B minus C. So here technically you have added, but internally you have done the subtraction. So you haven't violated the law of maths, but I think you have gotten the desired result as well. Are you listening and understanding that part, everyone? All the participants. Can I move ahead from here? Everybody watching and understanding this. Now, this is something again very interesting. If there are four numbers, understand and remember, both of them should be positive. So we are given that here A is less than B and C is less than D. Remember, all four of them are positive. All four of them are positive. So if A is less than B and C is less than D, then the product of two smaller positive numbers will be less than the product of two greater positive numbers. Remember this, AC will be less than BD. Similarly, another conclusion for equality also, this is true, but this should be always positive. Remember this, please don't do that. Subtraction or division cannot be done with inequalities. Sum and product can be done. Sum can always be done, but product, again, you should be aware of it that they should be positive. Then only product can be done. Otherwise, avoid doing it. Everybody listening and understanding this? Cross multiplication, please don't do that. So never do cross multiplication in inequalities. If you know the nature of the number, the variable by which you are doing the cross multiplication. So if you know the number, whether it is positive or negative. So if the number is positive and if you are doing the cross multiplication, then the sign wouldn't change. And if you know the number that it is negative and if you are doing the cross multiplication, then the sign would change. So you simply need to take care of the number. Don't do the cross multiplication. Simply remember that. Sir, if you want to do it, then there is a catch. I'll definitely share that trick or technique with an example, with an apt example. Don't worry about that. We'll definitely take certain number of examples. I hope you are watching it, understanding it, and without any confusion, you are getting it clearly. Now, divisibility test. We know for 2, the unit digit should be divisible by 3. If a number is said to be divisible by 3, the sum of its digits should be divisible by 3. If a number is needed to be checked whether it is divisible by 4 or not, what we do is we check the last 2 digits. We check the last 2 digits. For example, here 2025, and if I want to check what will be the remainder, when it is divided by 4, then please remember, just check the last 2 digits. Whatever remainder this 25 gives, that will be the remainder given by 2025 as well. So 4 into 6 is 24. So remainder here will be 1. When even 2025 is also divided by 4. Please remember that. When you talk about 5, the unit digit should be 0 or 5. When you talk about composite numbers, for example, let's say if I want to develop a rule for 24, if I wish to check whether 24 is divisible, 24 dividing a number or not. So first of all, try and write 24 as a product of co-prime numbers. So I know 24 can be written as 3 and 8, 3 into 8. Of course, you may say that 24 can be written as 4 and 6 as well, 4 into 6. But with 4 and 6, the problem here is that 4 and 6 are not co-prime. 4 and 6 are not a pair of co-prime. So I'll discard this 4 and 6. What I will choose is 3 and 8, which means whenever a number is divisible by 3 as well as 8, then it will always be divisible by 24. Did you understand my statement, all the participants? Everybody listening and understanding this? I hope you all are there without any confusion. Everybody with me on this? Now here, if I get back to this, if I talk about 6, 6 is a composite number, but I can write 6 as 2 into 3, product of 2 co-prime numbers. So 2 and 3, if can divide a number, then that number will be divisible by 6 as well. But that number should be divisible by 2 as well as 3. Will you remember that? From here, when you talk about number being divisible by 8, so for 4, the number's last 2 digits should be divisible. So here, if I am checking it, whether it is divisible by 8 or not, I'll check its last 3 digits. For example, here, 87512, and if I wish to check whether it is divisible by 8 or not, just check the last 3 digits are divisible or not. If the last 3 digits are divisible by 8, the number will also be divisible by 8. Will you remember that, all the participants? Now from here, when I go ahead, we talk about few more properties, few more divisions. The way we have developed the divisibility rule for 9, 3, the same rule is there for 9 as well. Sum of the digits, if they are divisible by 9, the number will also be divisible by 9. If a number is needed to be checked whether it is divisible by 10 or not, last digit should be 0. Now for 11, there is an interesting rule. Let's say the number is 4137852. Let's say this is the number and I wish to check whether it is divisible by 11 or not. So first of all, take the sum of all the odd numbers, odd position numbers, which means 2 plus 8 plus 3 plus 4. What does it give to you? Sir, 8 plus 2 is 10, 10 plus 3 is 13, 13 plus 4 is 17. So that number you have gotten 17. Then take these alternate digit sum, which is what? 7 plus 8, 8, 8 plus 5 is what? 13. So that is 13. And take the difference, I think the difference is found to be 0. Had I gotten this difference to be either 0 or a multiple of 11, I will say that, sir, this number is divisible by 11. But I've gotten the difference to be 4, hence I can very clearly see or say that this number is not going to be divisible by 4. Did you listen to that, or shall I repeat this part? What I'm saying is that difference of sum of alternate digits number when taken, and if it is found to be either 0 or a multiple of 11, then the number is said to be a multiple of 11. Everybody with me on this? Are you all listening and understanding this? Can I move ahead from here, all the participants? Now, when I go ahead, we talk few more about ratios and proportions. I hope you know the ratio and proportions. Few things which you should always be aware of is this, that with the ratios and proportions, you can always say that this result, which result, students, these two you all are aware of. Which one am I going to talk about? I am talking about this one, yes. When two ratios are there, let's say A by B is equal to C by D. So I hope most of you must have studied the rule of componendo and dividendo. This is very widely and prominently used in the questions of JEE mains. We'll be using this rule a lot many times. So the rule of componendo and dividendo says, let's say if somebody says that sir x by y is 2 by 3. Let's say x by y is, let's say, any number you take, let's say 6 is to 5, let's say you say. So x upon y is 6 is to 5. Let's say if I wish to make comments on x plus y upon x minus y. So there all I have done is componendo and dividendo, which means you can always say x plus y upon x minus y will be equal to 6 plus 5 upon 6 minus 5, which means it will be 11 is to 1. Did you all get that? Did you all understand this rule of componendo and dividendo? It is very highly used in the questions of JEE mains. Remember this, anywhere, at least in 2 questions, they use it directly or indirectly or subtly. Or a lot many times, questions can also be done with a lot of ease if you remember that. Great. Moving ahead from here, remember this result as well, that if certain ratios are given, let's say if I'm told that 2 is to 3 is equal to what, 4 is to 6 is equal to, let's say, 12 is to what, 18. So of course, this ratio will be equal to their sum as well, which means 2 plus 4 plus 12 divided by 3 plus 6 plus 18. Please remember that. What did I just say? I hope you all are listening and understanding. A upon B, C upon D, and E upon F, if they are equal, then A plus C plus E will be equal to B plus D plus F. I hope you got that. This is something very basic which you got to remember, because if you do, you will be applying them a lot in your questions. Now let's talk about polynomials. I hope you know polynomials means you begin with linear. For example, if I define a linear expression, it is ax plus b. So a and b are arbitrary constants. For example, here I'm taking them like 3x plus 2. So the power of x is 1. Here, if I wish to plot it, we know it is going to be a straight line. And if we wish to plot it, all we do is we replace x by 0. So when x becomes 0, what do we get? We get y as 2. So 0, 2 will be a point. And when I replace y by 0, I get x as minus 2 by 3. So I get x as minus 2 by 3. So this point will be here. And when I join it, this is how this line is drawn. So the point where it intersects the x-axis is said to be the root of the equation, which means it is intersecting the x-axis at minus 2, 3, minus 2 by 3, 0, which means this minus 2 by 3 is said to be the root of this equation, which means what? Let's say if I am saying or talking about a quadratic, x square minus 5x plus 6. I hope you know that. So here it will be a parabola. It is going to be a parabola. The way we have linear as a straight line, quadratic always gives you a parabola. It will be an upward facing parabola. We'll talk about this when we talk about quadratics in the bridge course only. And of course, if it is going to be an upward facing parabola, it will be having 2 roots or 2 solutions where it intersects the x-axis, and x-axis where it intersects will be having 2, 0 and 3, 0 as its roots. Which means when you replace x by 2 here, the y becomes 0. When you replace x by 3 there in the equation, y becomes 0. Everybody getting that? And of course, somewhere here, you'll be having the y-axis as well. Without any confusion, just give me a quick update. Are you all understanding this? All the participants. Now here we know one thing very clearly, that if this quadratic giving me a polynomial where it is a parabola, graphically, you will say that, sir, for cubic also we may get something. So let's say there is a cubic. Let's say there is a cubic, ax cube plus bx square plus cx plus d. Then do remember there are always 2 cases. 2 cases means either the coefficient of the highest degree term will be positive or negative. So whenever this a, the coefficient of x cube is positive, the graph will certainly be like this. And whenever the coefficient of x cube is negative, the graph will certainly be like this. Of course, what you cannot predict is where would x-axis be, because for that you need to find the roots. But if you could find x-axis, now see, there are 3 possibilities. X-axis could be here. So if x-axis is intersecting it here, it means it has one real root. Or x-axis could be here. So if x-axis is intersecting it at 2 points, it means here it is touching the curve, here it is intersecting this. So touching the curves means 2 repeated roots, and another one real root. So two distinct roots are there. Technically, three real roots are there, where two are the repeated roots. Or if x-axis is passing from here, it has three distinct roots. So depending on the x-axis, you can work out or talk about the roots. I repeat, in this case, it has one real and two imaginary or complex roots. Here, it has three real roots where two roots are repeated. In this case, if x-axis is here, it has three distinct roots. Everybody understanding that, all the participants. And that's where we say that the graph of cubic or odd degree polynomial goes from minus infinity to infinity or from infinity to minus infinity, which means their range is all the real numbers. They cover all the real numbers. On the y-axis, you can find y-axis to be anywhere. Y-axis could be here or anywhere. So y-axis covers everything, which means minus infinity to infinity. So odd degree polynomials give you all the values from minus infinity to infinity. But there is a catch. With even degree polynomials, you don't get like this. For example, if there is a polynomial y is equals to ax to the power 4 plus bx cube plus cx square plus dx plus e. So this is a biquadratic equation. With this biquadratic equation, what you are seeing is the coefficient of the highest degree term. The coefficient of x to the power 4 is a. So either it could be positive or negative. A could be either positive or negative. Again, if A is positive, the graph could be somewhat like this. It will come from infinity and it will go back to infinity. And when A is negative, the graph could be going like this, which means A could come from minus infinity and would go back to minus infinity. Which means in this case, it will have a minima, and in this case, it will have a maxima. So for even degree polynomials, we say its range is not from minus infinity to infinity. Which means, let's say, if the x-axis is passing through here, it has two real roots and two imaginary roots. If let's say x-axis is passing through this point, which means it is touching the curve here and it is intersecting the curves here. In this case, it has four real roots, two of them are distinct and two are getting repeated. When the curve is touched by the x-axis, the roots repeat. I hope you know that. If the x-axis is passing through here, I hope you are understanding, then you have four distinct real roots. I hope you have gotten a decent clarity here. With that, we talk about remainder theorem and factor theorem. What does it mean? Let me give you clarity with a simple example. Let's say if you have a polynomial, let's say quadratic we take, x square minus 5x plus 6. And if I ask you what will be the remainder, when f of x is divided by x minus 2, what will be the remainder? So what you do is, always remember the short technique says that remainder theorem for polynomial says that you put x minus 2 be equal to 0, which means you get x is equal to 2, and then you find f of 2. What is f of 2? You substitute x by 2, which means when x is substituted by 2, it will be 4 minus 10 plus 6, which is found to be 0. So yes, good Satyam. So when you find f of 2 and if it is found to be 0, which means here, when f of x is divided by x minus 2, it will give you a remainder 0. And I hope you remember, if a number is divisible by a number, which means if it gives a remainder 0, that means that number is a factor of this number. So first of all, did you get clarity on the remainder theorem? Let me take one more example. Let's say if I ask you a question, what will be the remainder when f of x is divided by x minus 1? So what will be your response? What will you do? You will say, sir, x minus 1 should be put equal to 0, which means you get x is equal to 1. So now you find f of 1. Now when you find f of 1 means what? 1 minus 5 plus 6. Correct me if I'm wrong. Which means what you get is minus 4 plus 6, which is 2. So when this f of x is divided by x minus 1, you get the remainder as 2. You need not divide this by x minus 1 and don't do that polynomial division. You can directly find the remainder. So that's the advantage. Of the remainder theorem. Will you all remember that? And there comes factor theorem as well, that when you apply the remainder theorem, and if the remainder is found to be 0, which means this is a factor of it. this divisor or divisor is a factor of it, which means here this is nothing but a factor theorem. So what is it in a nutshell? I'll say factor theorem and remainder theorem are nothing but simply what? When you're dividing a polynomial, let's say by x minus alpha. So that px when divided by x minus alpha, what remainder does it give you? Simply find p alpha. That p alpha will be your remainder. And if p alpha is found to be 0, then x minus alpha will be the factor of px. That is factor theorem. Just write it in the comment box quickly, all the participants. Did you understand remainder theorem and factor theorem, or shall I repeat this? All the participants, just quickly give me an update. Then we'll move ahead. Everybody with me on this, all the participants, you can look at this slide, which we have already covered. Don't worry about that. And here comes the most important identities. A lot many of these you all are already aware of, but there are few which you might have missed or may not have learnt or may not have revised or may not have memorized or may not have learnt, mugged up or crammed yet. And yes, in mathematics, you got to learn a lot of formulae. So yes, this is the part where I'll be saying that I hope you all clearly are aware of these. But if I talk about a plus b whole square, and if I say that I can write it as a minus b whole square plus 4ab, then I hope you're okay with that. Great, Satyam. I hope you're okay that this becomes a square plus b square minus 2ab plus 4ab makes it plus 2ab. So that is nothing but a plus b whole square. Sir, why are you discussing it like this? Because in mathematics only, we will be needing that sometimes I could be replacing a minus b whole square by a plus b whole square minus 4 alpha beta. I hope you remember, let's say I am given a quadratic ax square plus bx plus c is equals to 0, which has roots alpha and beta. And I am asked to figure out the difference between the roots. So difference between the roots means what? Alpha minus beta. Sir, how can we figure it out? We know alpha plus beta, we know alpha beta. Can somebody write the expression for alpha minus beta in the comment box? I'll be really happy and glad if you could tell me, how do we write alpha minus beta? Can I not say, sir, alpha minus beta as of now I cannot find, but alpha minus beta whole square I could write, because alpha minus beta I could write as alpha plus beta whole square minus 4 alpha beta. Why? Because it will be alpha square plus beta square plus 2 alpha beta minus 4 alpha beta. So cumulatively, it will be alpha square plus beta square minus 2 alpha beta, which is alpha minus beta whole square. But I hope you know, in quadratic, you all must have studied that alpha plus beta is what? Minus b upon a. So it should be b square upon a square. 4 alpha beta is c upon a. So it is 4c upon a. Now, one thing I'm going to do here, can I multiply the numerator and denominator by a? So when I take the LCM here, can I write it on the next slide? Here, I'll say alpha minus beta whole square, I receive as b square minus 4ac upon b square minus 4ac upon a square. Just give me a quick update on this, all the participants. Now, if I take square root on both these sides, this is how it looks like. Here, it will be square root over b square minus 4ac upon square root over a square. Now, I hope everybody is getting this result. Do you remember? It will not come out as alpha minus beta. Square root over square of alpha minus beta should be treated as mod of alpha minus beta. Do you remember that? All the participants here. And here, it should be under root d, because b square minus 4ac is nothing but discriminant, and it should be mod of a. Everybody got this? So difference of the roots in quadratic, if we need to deal with, I'll always be substituting it by root d upon mod a. So that's again a formula which you got to add in your list, which of course we'll be discussing, but yes, this is what you must have studied. Can I move ahead from here, all the participants? Now there were some more identities. I hope this is something you all must have studied a lot many times. A cube plus b cube plus 3ab times whole of a plus b, which is a plus b whole cube, and a cube minus b cube minus 3ab times whole of a minus b is a minus b whole cube. But with that, few more identities are derived. What are they? Let's say if I ask you a cube plus b cube, then can I not write it as a plus b whole cube minus 3ab times a plus b? I hope you all are listening and understanding that. And from here, if I take a plus b common, I'll be left with a plus b whole square minus 3ab. So when I simplify that part, I hope you're understanding, I'll be get it as a square. 2ab minus 3ab is minus ab plus b square. Now, how I personally remember it, because we'll be using it a lot many times. So I personally remember it like this, that whatever sign is there, that same sign is here. Whatever sign is here, opposite of that sign is seen here. And remember one thing, that the sign before a square and b square is always positive. What did I just say? All I'm saying is that, let's say if I ask you to figure out a cube minus b cube, then one of the factors will be there with a and b, other factor will be there with ab, a square and b square. So how do I decide signs? I often forget this, but how do I remember it? Whatever sign is here, that same sign will be here, and opposite to that will be here. And a square and b square are always positive. Will you remember it? Will you remember it now? I hope all the participants, that's good, Arkajana, all the participants who are listening, watching and understanding, everybody getting this? Now from here, when I go ahead or when I talk back about few more identities, they are going to be this one. Pay attention to this. A plus b plus c whole square, we all know, is nothing but a square plus b square plus c square plus 2ab plus 2bc plus 2c. But if I take 2abc common from here, then I'll be left with 1 by c, 1 by a and 1 by b. So yes, this is also another version of a plus b plus c whole square, which is a square plus b square plus c square plus 2abc times 1 by a plus 1 by b plus 1 by c. As per the need of the question, we could be using this version instead of that version. Everybody listening, watching and understanding, that's good, students. Keep responding, keep interacting, keep participating. That's how you keep yourself active, engaged and learning. Now with that, yes, this is again another version. I'll be talking about this one first of all. Let me talk about this. A cube, pay attention to this part. This is something which JEE is in love with. They ask you to apply it at a lot of places. So remember this. This is something which is very prominently used and asked by JEE at a lot of places a lot many times. What is it? A cube plus b cube plus c cube minus 3abc. It is always a plus b plus c times a square plus b square plus c square minus ab minus bc minus ca. If you don't know it yet, memorize it, revise it. And I hope you know that after the session, this entire PDF will be delivered to you at absolutely free of cost. All you need to do is check the description. You are given the link, and by following which you can definitely get this PDF as well. Now, coming back to the discussion we all were having here, there are some conclusions which can be drawn. First conclusion, if I multiply this part by 2 and divide this part by 2, what do I get? If I'm dividing it by 2, so that 2 I'm keeping outside. And if I'm multiplying it inside, I'll have 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Everybody listening and understanding? All the participants, give me a quick response. Now from here, I know that it is 1 by 2 times whole of a plus b plus c. But here, pay attention to this part. A square plus b square minus 2ab. Can I not write that as a minus b whole square? Then I'm still left with 1a square and 1b square. So b square plus c square minus 2bc. Can I not write that as b minus c whole square? Then I'm still left with 1a square and 1c square. So c square plus a square minus 2ca. Can I not replace that by c minus a whole square? So you got to remember this result as well, that here this a cube plus b cube plus c cube minus 3abc can be written like this as well. Sir, why are we discussing it? Yes, it is used a lot of places. From here, you got to remember one more identity, that a square plus b square plus c square minus ab minus bc minus ca, as per the need of the question, can be written as a minus b whole square plus b minus c whole square plus c minus a whole square. Will you all remember that? Now there is one more conclusion, a very interesting one. If a plus b plus c is 0, then what did I just say? If a plus b plus c is 0, then can I not say a cube plus b cube plus c cube will be equal to 3abc? Just cross check it and give me a confirmation whether you have understood it or not. Can you write the explanation behind this in the comment box? Anyone? How did I get it? I hope most of you must have been seeing this, that sir, if a plus b plus c is 0, which means 0 into anything is 0. So here a cube plus b cube plus c cube minus 3abc becomes 0, which means a cube plus b cube plus c cube becomes 3abc. Did you all get that? All the participants. From here, when I go ahead, what do we see? Few more. I hope you clearly know that a to the power 4 minus b to the power 4. I can write that as a square minus b square times a square plus b square. Are you getting it? Because a to the power 4 can be written as square of a square minus square of b square. So that can be written as a square minus b square, a square plus b square. So a square plus b square stays like that, but a square minus b square can be written as a plus b into a minus b. Again, if I tell you something more interesting, which is very useful, which is very widely used, or again most asked by JEE mains, is this one. In telescoping some based questions, in questions of inverse trigonometric functions based questions, this is something which they very often ask, which they ask you to use a lot many times. What is it? A to the power 4 plus a square plus 1. What is it? I repeat, this identity is a to the power 4 plus a square plus 1. Now pay attention to this part. What I'm going to do here is a to the power 4 can I write as a square whole square? Here I am having a 2a square. Sir, how can you have it as 2a square if it was a square? Since I am writing it as 2a square, can I not subtract an a square from here? I hope that can be done and you're comfortable with that. Why did I do that here? If you pay attention to this part, how does it look like? Is it not a square plus b square plus 2ab? Yes, Satyam, you will get the PDF on our PW website, on our PW app as well. I hope you got that. On the PW app, when you log in by providing your credentials, which is of course for free, you go to the bridge course, you enroll for it, which is again absolutely free. And by enrolling for the course, you get the PDF of this. Okay, you get the entire PDF. Now here, if I get back to this, I hope you're understanding. This we write as a plus b whole square. So that a is here a square and b is 1. So it is a square plus 1 whole square. And that is minus a square. So can I write that as a square? Now again, are you not seeing it to be a square minus b square, where a is a square plus 1 and b is a? I hope my language is understandable. So from there, can I not say it will be written as a plus b into a minus b? So a plus b is going to be a square plus 1 plus a, and a minus b will be written as a square plus 1 minus a. When it is rearranged, it looks like a square plus a plus 1 and a square minus a plus 1. What is it? It is the expansion of a to the power 4 plus a square plus 1. I am humbly requesting you all to memorize this, to keep a note of this, because this is something which you would be using at a lot of places in your JEE journey. Now, if I get back to the conclusion, these are again few more which are not being discussed. We'll be discussing them in the respective chapters or as per the questions. But yes, this is something you should be aware of. Something again very crucial is this one. Can somebody help me with the explanation of this? How do you prove this? I hope some of you must have realized that, sir, here it is nothing but what? If you multiply and divide it by x minus 1. So here I hope you're understanding. If you multiply and divide it by x minus 1. So x minus 1 with x plus 1 becomes x square minus 1. X square minus 1 with x square plus 1 becomes x to the power 4 minus 1. X to the power 4 minus 1 with x to the power 4 plus 1 becomes x to the power 8 minus 1. A plus b into a minus b, I'm applying constantly. So ultimately, I have gotten this clarity that in the end, I'll get x to the power 2n minus 1, which when multiplied gives you x to the power 2n minus 1, or x minus 1 will be there in the denominator, because this we have already introduced. So did you all get this result? Did you all understand the proof as well? How did we prove it? Just give me a quick update. Are we all matching with each other's frequency? The kind of speed at which I'm teaching you, are you comfortably understanding this? I hope it is okay and fine that we can continue with this pace. Everybody with me on this? Now from here, when I go ahead, what do we see next? Yes. Cyclic factors are simply this, nothing but if there is an expression where ABC have cyclicity, which means if A is replaced by B, B is replaced by C, and C is replaced by A, then also that expression remains same, then such expression is called cyclic factor. I hope you understand that. Its factors are called cyclic factors. Everybody got this? I hope no confusion on that. From here, when I go ahead or talk about few more conclusions, let's say sometimes what you're asked is, great. Thank you so much for that, Satyam. So I'm hoping that you are understanding all these things. If it is a little fast, I get this. Okay. From here, let's talk about this result. A lot many times what we do is we are asked to solve a question. We are asked to solve a question. And in that question, how should I explain this part? And in that question, let's say I'm given a question x square x cube minus 1 is equal to, let's say, x square. Technically, this is not how the question may look like. The question may look like x cube minus x square minus 1 is equal to 0. So let's say that's the question. Let's say this is the question, right? So one of the methods to solve this question is that here, if I push this x square to the other side, solving means I'm interested in finding the roots or at least the number of roots. So how can I solve this? I may say that, sir, x cube minus 1 you keep on one side and x square you put on the other side. So here you treat x cube minus 1 as one function. So let's say f of x is a function which is x cube minus 1 and g of x is another function which is x square. Now, if we are comfortable with the graphs, we may talk a lot about a lot of things. What do I mean by that? Can we draw the graph of x cube minus 1? So first of all, when you talk about the graph of x cube, which we'll discuss when we talk about the chapter functions, I know it, you will also know it very soon. So here, if I'm drawing the graph of x cube, it is drawn like this. This is how you draw the graph of x cube minus 1. Sorry, x cube. But if I'm drawing the graph of x cube minus 1, I'll shift this graph 1 unit below along the y-axis. So this is how you draw the graph of x cube minus 1. This is nothing but the graph of f of x, which is nothing but x cube minus 1. Now, when you talk about the graph of x square, pay attention to this part. The graph of x square goes like this. The graph of x square. Sir, will you take the concept lectures beside one shots? Nicholas Tesla, I did not understand your query. Will you take the concept lectures beside one shots? I'm not understanding the context in which you are asking. Is it regarding 11th or 12th or for the JEE means April attempt? For which are you asking this? Be more specific. Now here, this is the graph of g of x, which is what? X square. So when I drew these two graphs, I clearly saw that these two graphs are intersecting at one point. I am not interested in that point as of now, but what I'm interested in that they are intersecting at one point, which means f of x and g of x have a mutual point, have a common point, where both of them become equal. Where there is a point, I don't know that point, but here there is a point, let's say h comma f of h, h comma g of h or h comma k, whatever point it is, there both of the graphs are getting satisfied. Both of them are equal, which means f of x and g of x both are equal for certain value of x, which I don't know. But if I were to answer this question that how many solutions will be there, I'll say one real root will be there, at least one. Although for a cubic, you can always say minimum one real root will be there. Since it is cubic, I will say its graph could be somewhat like this, which means it is going from minus infinity to plus infinity, which means it is always going to intersect x-axis at least one. I repeat, for odd degree polynomials, there is always one real root. There is always minimum one real root. There is always at least one real root. But I was supposed to answer this, so I'll say there will be one real and exactly two imaginary. And of course, when you talk about imaginary roots, they come in pairs. They are conjugate of each other. Taking concept-wise lecture per chapter to cover JEE Mains and Advanced. I think yes, Nicholas, on this YouTube channel, on our channel, PW JEE English. This is PW English medium, where we are running our bridge course. Possibly, PW JEE English channel is where we'll be taking care of all these things which you are requesting. Don't worry about that. We'll be covering that. Now, from here, when I go ahead, Let's talk about few more things as we have already discussed this part. Rational function is simply another a category of function which simply is a function like this. Let's say you have x plus 3 divided by x square plus 2x plus 3. Then such functions, a polynomial upon polynomial, is said to be a rational function. We'll talk about this when we talk about functions. Don't worry about that. But now when I talk about this part, now we talk about law of indices. So let's have a 10 minutes break. It is 7:20 right now. We'll resume at 7:20. So we are having or taking a 10 minutes break. Okay, we'll resume at 7:20. I hope it's fine, everybody. Hello, hello, hello. Students, give me a response. Am I clearly audible? Okay, so let's resume or let's revert back. Here we are. There is some. I hope you can hear me properly. Can we resume with our session? I hope you all are there, listening, watching, and understanding. Okay, so let us resume. I hope you all are there, listening, watching, and understanding. Give me a quick update. Give me a quick response, everybody. I hope I'm clearly visible and audible to all the participants. Let me just refresh the screen from my end as well. No one is even watching you. Great, great, great user. Thank you so much for that. That inspires us to do better. Great. Moving ahead with this, laws of indices. If I could begin with this conclusion, here we are. A to the power 0, we all know is 1. A to the power minus m is 1 by m. When bases are same, powers are added. When division is done, powers are subtracted. This is something we all know. You all know. We are just giving you a quick review. But this is something where students commit a lot of mistakes. And this is the part I wanted to highlight. Pay attention to this part here. Let's say whenever x is y, whenever x is equal to y, then we can say a to the power x is equal to a to the power y. But the converse is not true. Converse means what? Converse means if somebody says that sir a to the power x is equal to a to the power y. I repeat, where a is an arbitrary constant. So somebody says a to the power x is equals to a to the power y. Does it imply x is equal to y? Not necessarily always. Did you get that? Shall I repeat that part? I repeat my part very clearly. If a to the power x is equal to a to the power y, then there are a lot of possibilities. First possibility, yes, if and only if a is not plus minus 1 or 0. If a is not plus minus 1 or 0, then definitely x could be y. But three things. If a is 1 or if a is minus 1 or if a is 0, then the things may change. I hope you're understanding. If a is 1, we don't know a. A is an arbitrary constant. So if a is an arbitrary constant and if you raise 1 to any power, then can you conclude x and y should be necessarily equal? If the base becomes 1, then x and y could be any number. Could be any number. So in that case, if a is 1, then x and y could be any real number. I hope you got that. Second conclusion. If this is the first conclusion, when a is equal to 1, then yes, x and y could be any real number. What about a being minus 1? What about a being minus 1? I hope you could see this clearly. If a is minus 1, then we can clearly say that x and y both should be even. Why? Because if minus 1 is raised to the power x and minus 1 is raised to the power y, and if we are told that it is equal, then I hope you know it will be equal only when x and y are either both odd or both even. Are you listening and understanding this? So in this case, when x is minus 1, then I'll say that x comma y should be either both even or both should be odd. Everybody listening and understanding this part? Can I move ahead from here? Now the third conclusion, if a is 0, if a becomes 0, then of course we know in mathematics 0 to the power 0 is an indeterminate form. It is an indeterminate form. Indeterminate form, which means it cannot be figured out. I'm not talking about infinity. Infinity is a amazingly large number. We can approach infinity. But when you talk about indeterminate form, for example, 0 upon 0, 1 to the power infinity, 0 to the power 0, they are the indeterminate forms. So there we cannot figure out the value of 0 to the power 0 because a logic may say that anything raised to the power 0 is 1. But some of you may say, sir, 0 to the power anything is 0. So it is either 1 or 0. So this is clearly an indeterminate form. So there you got to understand this result that when base is 0, then x and y can be any real number except for 0. I repeat my conclusion. Let me just refresh this screen. Hold on for a while so that I can see all of you here. All I'm saying is a very simple conclusion, participants. The conclusion is straightforward and a simple one. What is it? What is happening with the screen I'm having? It has hanged. Okay, great. I cannot see anything. Are you all there? Because the screen has crashed. Hold on for a while. I hope it's visible now and I'm clearly audible. Yes, great. Now getting back to the conclusion, all I'm saying is that whenever somebody says a to the power x is equal to a to the power y, then it is not necessarily true that x is equal to y. It will be true if I know clearly that a is not -1, 0 or 1. So if a is neither -1, 0 or 1, in that case, I'll say that yes, x will be y. If a to the power x is equals to a to the power y. Otherwise, these are the other three possibilities. I should be aware of that. Everybody getting that? All the participants. Now from here, when I go ahead, what I see next is, yes, this is all what we have already discussed. No, this is the other version. Now this is a to the power x is equals to b to the power x. I'll explain it here only. Let's say if I am told that a to the power x is equal to b to the power x. So this time what is there? Sir, powers are same. Bases are different. So if powers are same, then also can I say that bases will be same? Again, some conclusions come into picture. What are those conclusions? Pay attention to that. Pay attention to that. Look at this part. If a is not equal to plus minus b, then the only case is x is equal to 0. What does it mean? Let's say I take 3 to the power 0 and 5 to the power 0. Then of course both are 1 and it is true. If somebody says a to the power x is equal to b to the power x, then it will be true if it will be true for x is equal to 0 for any value of a and b. That's exactly what we are told in this first statement. If a is not equal to plus minus b, this means a is neither plus a, plus b or minus b. In that case, this will be true only when x is 0. Are you all getting that? Everybody with me on this? Second conclusion, if a and b both are equal and both are not 0, then x can have any real value. I hope you are getting it. If a and b both are non-zero, then x may have any real value. I hope this part is also very well understood by you all. Third conclusion, if a is equal to minus b, then x is even. I hope you are understanding. If I claim, I'm really sorry, there should be a typing error here. This is a to the power x, b to the power x, right? Yes, nothing wrong in that. It is absolutely right. Let me take one more example to make you understand this. Let's say if I say 3 to the power x is equal to minus 3 to the power x. Can it be true? Can it be true for any real number? I would doubt so, because here it will be true if x is found to be an even number. Because if x is odd, I hope you're realizing this will be positive, this will be negative. So in that case, if a is equal to minus b, then x should be an even number. So I have all the three cases are very well understood by you all. Can I move ahead from here? All the participants. Now let's talk about the next conclusion. Yes, this is something based on the previous result or the previous discussion we had. I'll try to make you understand with a very simple example, not with the functions. What does it mean? It means, let's say I am given a to the power x is equal to b to the power y. Let's say I'm told a to the power x is equal to b to the power y. Now, what conclusions can be drawn? The first possibility. Here, three things are there. Pay attention to that part. If we have to solve this kind of equations where a to the power x is equal to b to the power y, where all of these are variable, let's say for a while. So I'll take some other numbers. Let's say I take 4 variables. So w to the power x and let's say is equals to v to the power y. So w and v are not arbitrary constants. Here, and one of them is me. 4 people are watching, one is you, one is me. So I think there are only 2 technically watching. Good. Hello, hi, namaskar everyone. So here I'll say that x and y and w and v all are variables. First part, I hope you have understood that. Now from here, when I go ahead with this conclusion, that how or what kind of conclusions do we draw from here? So we'll draw conclusion based on these 3 conditions. Satyam, let's focus here. First possibility could be w and v could be equal. Second possibility, w could be equal to minus v. And the third possibility could be, here I'm taking only one variable in the power. So let's say w to the power x, or let me take it as a to the power x is equals to a to the power y. I hope that's a case which you have seen similarly. So there are 3 possibilities. First possibility will be, or here, power is treated to be same. So let's say this is a to the power x is equals to b to the power x. That's the case. So 3 things will be there. First case, either a will be equal to b, because if power is any real number, a and b could be any numbers, but they should be equal in that case. Second case, if power is even, then a can afford to be negative of b, I hope you are deriving this case where we have discussed it. Third case, sir, if power is 0, then A and B don't matter. I hope you're understanding whatever conclusion I'm giving here is based on what we have already discussed. Now, here, let us go ahead from here. What do we discuss here about surds? Surds and indices. So pay attention about that part. Root over 5 plus root 7 is not a surd, but how do we define surd? We define surds in simple manner that whenever nth root of a number is taken, then it is called a surd. For example, here I'm taking root 3. So this is called a surd. So when nth roots of a number, for example, let's say I'm raising 7 to its 1/3 power. So third root of 7 is being taken, which is, I hope you're understanding, third root of 7 is like this. So this is a surd. But remember, this 5 plus root 7, which means if you are clubbing an irrational number with a rational number or surd with a normal rational number, and if you are taking its square root or nth root, then it is not a surd. Surd is simply a number whose nth root is being taken. Factorial, let's talk about. I hope most of you must have studied it in a simpler language. If I'm talking about factorial of a number, by some people it is denoted like this, by some people it is denoted like this. It's simply nothing but product of first n natural numbers. So if I'm taking 5 factorial, it means product of first 5 natural numbers. Everybody getting it? For factorial notation, what is true is that 5 factorial can also be written as, let's say, 5 into 4 into 3. Can I write 3 as 3 factorial? Because 3 into 2 into 1 can be 3 factorial. So always remember, if I'm working on n factorial, I'll maybe writing it as n into n minus 1 factorial as per the NEET. Few more things you should be aware of is what? If I am asking you 1 factorial, it is 1. Even if I'm asking you 0 factorial, then also it is 0. It is 1. It is not 0. Please remember that. How do we prove it? When we study permutation and combinations, there I'll explain it. Why 0 factorial is 1? Don't worry about that. Everybody is understanding, listening, and clearly getting it, all the participants. Now from here, when I go ahead, what do we study or talk about next is, these are the results. I'll request you to memorize these values. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 24 into 5, which is 120, 6 factorial is 6 into 5 factorial, which is 720, and so on. So until 10 factorial, you should have these values at your fingertips. Did you all get that? Please remember this, because if you memorize them, they'll be saving a lot of time of yours in the examination hall. Now let's talk about root loss and root gain. Now let's talk about root loss and root gain. Let's talk it about in a very, very clear manner. Let's say I'm solving an equation x cube minus x square is equal to x. Let's say I'm solving this equation. Now, when I solve this equation here, let's say I'm taking x common. So if I take x common, it will be x. It will leave me with x square. I hope you're understanding. Minus x. Or I could have taken x square also common. So if I'm taking x square common, it will leave me with x minus 1 is equal to x. Now, if some of you believe or think that, sir, this x and this x should be cancelled, okay, let's cancel it. So if I'm cancelling this, I hope this x is getting cancelled by this. So you're left with x times x minus 1 is equal to 1. Everybody listening and understanding this? Now, when I solve this further, what I get is x square minus x minus 1 is equal to 0. I hope you all are learning, understanding this very clearly. What I'm getting is x square minus x minus 1 is equal to 0. Let's talk about its discriminant. So its discriminant will be what? B square minus 4ac. So its discriminant is positive, roots are real. So if I find its roots are going to be what? Minus b, which is 1, plus minus under root over b square minus 4ac. So 1, b square is 1, minus 4ac, that is plus 4. So 1 plus 4 is 5 upon 2a, that is 2. So I have gotten two roots. Out of which one of the real roots is 1 plus root 5 by 2. Other root is 1 minus root 5 by 2. But if I go back to the original equation, it was x cube minus x square minus x is equal to 0. So technically, it was a cubic equation. And if it was a cubic equation, I hope you're realizing it cannot have two real roots and one imaginary root. I hope you're understanding, because it is a cubic. In that case, it will have exactly one real root or two imaginary, or all the three roots could be real. I hope you're understanding. But you cannot have two real roots and one imaginary, because we know with the theory of equations that imaginary roots come in pair. They are conjugate of each other. So if one of the roots is 2 plus root 3, other root will be 2 minus root, sorry, one of the roots is 2 plus 3 iota, other root will be 2 minus 3 iota. So here, I hope you're understanding, I must have made a mistake. And that mistake is the mistake of root loss. Now, what is root loss? You just cannot cancel a variable by a variable. I repeat, if you are cancelling a variable by a variable in an equation, you are making the root loss happen, which means the possibility of x being 0 is discarded or eliminated by you. I repeat, whenever you are solving equations, don't cancel a variable by a variable. Yes. Here. So when you take x common from here, it will leave you with x square minus x minus 1 is equals to 0. And when you solve this, x becomes 0. And this part gives you other two roots, which are, of course, 1 plus root 5 by 2 and 1 minus root 5 by 2. Everybody listening and understanding this part, all the participants? So I hope you got this very clearly, everybody, that 3 roots were supposed to be there and 3 real roots were supposed to be there, and 1 root loss has happened, all because of this simple Siri error made by us where we cancelled a variable by a variable. So remember this, when you solve the equations, don't cancel a variable by a variable. If you do so, consider the value of that variable to be 0. Let's say if I had cancelled it here, in that case, I should have taken the value of x to be 0. That is one of the solutions which I should carry with me. Everybody got that? All the participants? Now from here, when I move ahead, what I see next is, yes, as we have already discussed, for example here, if I'm taking x common from here, so it will be leaving me with x minus 2 is equal to x minus 2. Now again the same problem. If you are cancelling x minus 2 by x minus 2, good to go. But in that case, variable by a variable, so take the variable as 0. So if I'm cancelling x minus 2 by x minus 2, you got to take x minus 2 as 0, which means x as 2. And the other result is when this and this are cancelled, you are left with x is 1. So there are two roots, x is equal to 1 and x is equals to 2. But if you simply cancel this variable by variable, x is equal to 1 you get, and you get only 2 root. If it was a quadratic, how can you have only 1 root? Some of the students or some of intelligent students in the comment box might say that, sir, you could have taken it on the left hand side. Yes, by doing so, you can convert it into a quadratic and then solve it. Everybody with me on this? Now, from here, when I go ahead, what I see next is, yes, the values of x square from the given values of x. Now, what does it mean? Pay attention to that part. Let's say if somebody says that there is x which lies, or if I talk about this part only, there is x which lies from 2 to 4. Closed interval 2 to 4. I could have written it like this only, that here there is x which takes all the values from 2 to 4. Everybody listening and understanding this? Now from here, all I'm saying is that let's say if as per the question or as per the need of the question, I need to square it, or if I wish to make some comments on the values of x square, then what can I say? Now try and imagine you have all the numbers from 2 to 4. Imagine 2, 2.1, 2.2, 3, 3.9 and 4. So if you square all these numbers, what will be the lowest number and what will be the greatest number you'll get? So I hope most of you must clearly be cracking. Sir, I'll get all the numbers from 4 to 16. That's simple, that's easy, that's absolutely understandable. But let's say instead of this, what if I had x, let's say from minus 7 to minus 2. In that case, what will happen? Now imagine you have numbers minus 7, minus 6, minus 5, minus 4.9, minus 3, minus 2.1 and minus 2. All these numbers are there with you. If you square all these numbers, what will be least value and what will be greatest value? Which means if I now talk about x square, what will I get? I'll say, sir, the least value will be minus 2 square, which is 4. And the greatest value will be minus 7 square, which is 49. Everybody got that part as well? All the participants. Are we clear on this? Can I move ahead from here? Then let's talk about few more results. Few more results means, let's say if I say that x is let's say from let's say minus 5 to 3. In that case, what you say? Can you write it in the comment box, students? Sir, if x is from minus 5 to 3, then what will be happening? Yes, Satyam, we are bringing you the classes in this bridge course for all the subjects, not just for physics, chemistry and maths, for biology, for all the subjects of PCMB. Don't worry about that. If I get back to the discussion we were having, can you write it in the comment box? What could be the answer here? If x is a number which lies from -5 to 3, what can you comment about x square? What will be your answer in that case? So now imagine there are numbers from -5 to 3. -5 to 3. Now in that case, imagine -5, -4, 3, 2, 1, 0, 1, 2. So if all these numbers are squared, what will be the least value? Do you not think, sir, the least value will be 0 square? And what will be the greatest value? Sir, till this 3, I'll be getting 9. And till this -5, I'll be getting 25. So I think I'll be getting all the values from 0 to 25. Everybody got that? Everybody understood that? Are you all there? Let's say I take one more example to make you more clear on this. Let's say here x takes all the values from let's say -7 to 5. Or let's say -7 to 9. Now what will be your answer? Great, good students. Now what will be your answer? Can you say something about x square? Yes, good students. So here again, if I talk about x square, -7 to 9. So the least value here will be 0 square. Because 0 to -7 when squared give you 0 to 49. 0 to 9 when squared give you 0 to 81. So 0 is going to be the least value that you are going to get because there is 0 between -7 to 9. So x square's minimum value is 0. Then can you help me with the largest possible value? Will it be 49 or 81? Will it be 49 or 81? So I hope you're understanding the largest value here will be 81. But can you help me with the equality sign? Will it be equal to 81 or simply less than 81? I hope you're understanding. Here 9 is not included. So of course 81 is also not going to be included. Everybody got that? All the participants. Can I go ahead from here? Now here. When I move ahead, what do I see? Next is this part that can we predict 1 by x as well from the values of x? Let's go ahead with that. Let's say if I say that x is greater than 3. X is greater than 3. Now, if I ask you to talk about the values of 1 by x, can you say something about that? Now here, if I am asking you to put your comments on 1 by x, will you not say, sir, since x is greater than 3, okay, I will write in a little different manner so that it becomes more understandable. We know that x is greater than 3. Can I write it like this? So if I'm taking the reciprocal, all you got to remember is that here you are taking the reciprocal on both the sides. So when you take the reciprocal, the sign changes. So if x is greater than 3, 1 by x will be less than 1 by 3. Did you understand that? If you are taking the reciprocal, all what happens is that the sign changes. The way we have been doing with the negative numbers, let's say if a is greater than b, and if you are multiplying both these sides by a negative number, then the sign of the inequality changes. The same thing is going to happen here. If x is greater than 3, then 1 by x will be less than 1 by 3. Now, sir, it is less than 1 by 3. But up to what extent? Will it be greater than some number? Now please understand, x is greater than 3, which means what? It is always less than infinity, although you don't write it like this mathematically, but just to make you understand this, I'm trying to give you more clarity on this. Now here, when I'm taking the reciprocal, it will be 1 by infinity, and 1 by infinity is what? 0. Are you getting what I'm saying? Are you getting what I'm saying? Technically, the graph of reciprocal function looks like this. The graph of reciprocal function looks like this. I hope you're understanding. Let's say here, the graph of reciprocal function means this is y is equals to 1 by x. So I repeat, when x was greater than 3, so this is here, this point here is your 3. So when you move from 3, so at 3, the value of the function which you receive is 1 by 3. So when you move ahead of 3, when you take all the values of x which are greater than 3, you start getting values of y which are less than 1 by 3. I hope you're understanding it. And as x approaches infinity, your 1 by 3 approaches 0. Are you understanding in this language which I'm trying to come up with? I hope this part you can directly understand. But if you want to make some sense out of it graphically, this is how you build it. All the participants, everybody got this. Can I move ahead from here? Now, one thing you should be understanding is that here x was positive, that is from 3 to infinity. Let's take one more example. Here, let's say if I say that, sir, x is less than -5. Here also, what is luckily what we have is that x is taking all the negative values. And of course, if x is less than -5, it must be greater than -infinity. If it is less than -5, which means all the values less than -5. So here, I'll be seeing the value of x to be -5. So here at -5, the value of y will be what? -1/5. So if I take reciprocal on both the sides, yes. Here, if I take reciprocal on both the sides, what will I have? I have an understanding 1/x. The sign less than becomes greater than -1/5. Are you listening and understanding this? Or shall I repeat this part? I repeat, I'm really sorry. Yes, we are going great. X is less than -5, right? So if x is less than -5 means what? I am taking all the values of x which are less than -5. I hope you're understanding it. So when I'm going back from -5 towards -infinity, here on the graph, I'm going above. So if you're moving above, if you're going above on the y-axis, you're going above of -1/5 like this towards 0. I hope you all are understanding and listening and clearly getting this. So from here, I'll say the values of 1/x will be greater than -1/5. Everybody with me on this, all the participants. Now here, I hope you're understanding that's exactly what we have concluded, that if x was less than -5, its reciprocal 1/x will be greater than -1/5. Everybody with me on this? And of course, reciprocal of 1/infinity will be 0. So yes, if it is greater than -1/5, it will up to go to an extent which is 0. Because here, when x approaches -infinity, 1/x approaches 0. So are you able to understand this part graphically, or shall I repeat this? Let's take one more example so that you build more clarity on this concept. Everybody with me so far without any confusion? So far what we have done is x was either greater than a positive value, so all the values were either positive, or x was either less than the negative value, which means all the values were negative. What if x lies between a negative and a positive value? Then also can we take the reciprocal? Yes. How? Let's take this example in a more clearer manner. I hope you all are paying attention here. First of all, let's again draw the graph so that you visualize it graphically as well and you can get more clarity. This is the graph of y is equals to 1/x. And here, let me say that there is a value x which lies between, let's say -4 to 7. And -4 is included, let's say, for a while, so that you get more clarity on equality sign as well. So here, let's say you will have 7 somewhere here. Let's say you'll have 7 somewhere here and -4 somewhere here. Everybody with me on this? Now, please pay attention to this part. There is a small catch here where students commit a lot of mistakes. Which is that part here? This is going to be 0. Now, I am taking all the values of x from -4 to 7. But when I talk about reciprocal of x, there is a catch. Sir, can I afford to keep x to be 0? Can I keep x as 0? Are you understanding this? Because if I put x as 0, then 1/x will be not defined. So I think that value needs to be excluded. So I now will consider all the values of x from -4 to 0, excluding 0, and then from 0 to 7, again excluding 0. Did you all get that part, or shall I repeat this? All the participants. So from here, first of all, this is -4. Where what I get is -1/4. This is 7. Where what I get is 1/7. So from -4, if I start taking greater values than -4, I'm approaching towards 0 on the x-axis. With that, I hope you are seeing this part graphically very clearly, that from -4, if you are moving towards 0, graphically, you are moving towards -infinity from -1/4 on the y-axis. On the y-axis, I hope you are getting it very clearly. This is the graph of y is equals to 1/x, my dear everyone. Which means if x was from -4 to 0, 1/x will be from -infinity to -1/4. So here, first of all, I'll be saying that 1/x will be from -infinity to -1/4. But pay attention to this part. -4 was included, which means -1/4 will also be included. Or means union. Everybody with me on this? Now, if or means union means what? This is 0. 0 cannot be included because 1/x will be not defined there. But now, from 0, if I start moving towards x, so I have started moving towards x. So from 0, if I have started moving towards x, which means these values I'm taking. So technically, from 0, if you start moving towards x, you are moving from infinity, You are moving from infinity to 1 by 7 on the y-axis. I hope you are seeing you are moving from infinity to 1 by 7 on the y-axis. So I'm taking all the values. When x goes from 0 to 7, y goes from 1 by 7 to infinity. I hope you are listening and understanding. So other part will be from 1 by 7 to infinity. Of course, we never include infinity and minus infinity. But 1 by 7. Sir, was 7 included? No. So will I include 1 by 7? No. Everybody got this. All the participants. Everybody with me on this. Graphically, are you able to visualize this? Logical explanation are you getting from here? I am saying that this is not what you should always do, but what you should always do is that you should be able to write this direct result from here. If I could repeat the direct result, what will be the direct result? Pay attention to this part, all these students, that if x is from minus a to b, x is from minus a to b, then 1 by x will be from minus infinity to minus 1 by a, or that means union 1 by b to infinity. If x lies from negative to a positive value, 1 by x goes like this. Everybody with me this? All the participants, did you all get this? Can we move ahead from here if you have gotten clarity about that? Now, here let's talk about this. One of the expressions I am asking you to solve. Let's say this is what I'm giving you as a homework because I'll be explaining this part. So let's try and solve x square minus 2x plus 10 inside an under root. There we are asked to figure out all the possible values of this expression. One of the methods is you use quadratic. Second is you use application of derivatives. Third is at this stage, since we are using it in a bridge course, I am asking you to convert it into a perfect square. Now, how do we define it as a perfect square? Pay attention to this. This part I'm solving. This part you can solve by yourself. This question here, x square minus 2x. Can I split or break this 10 into two parts where I'm writing it as 1 plus 9? I'm deliberately doing it because I can see something here, which means here it is an inside an under root sign. So this part I have split it here like this. I hope you're okay with that. When I do so, what I get from here is that it is under root over. I hope you can see a square plus b square minus 2ab. So it is clearly nothing but what? X minus 1 whole square plus 9. Everybody understood that? All the participants. Now from here, when I go ahead, now let me take you back towards the discussion we were having. What was the discussion? Can you say, let's say, sir, for a while, let's assume x can be any real number. Let's assume. Although whether it can be, we don't know, but let's assume for a while. So can you say something about x minus 1 whole square? Sir, x minus 1 will also be a real number, but x minus 1 whole square will always be a non-negative number. I hope you're getting it, since it is a perfect square, and perfect squares are always non-negative, which means they are either 0 or greater than 0, which means x minus 1 whole square is always greater than equal to 0. Everybody got that? Everybody got that? From here, if I add 9 to both the sides, I hope you remember in inequalities we did discuss that same number can be added to both the sides. The inequalities are not affected. So with that, what will I say? Sir, x minus 1 whole square plus 9 is greater than equal to 9. So I think we have gotten the answer. Although a JEE aspirant doesn't do it like this, they technically delve deeper and see it directly here. That's a, this is a perfect square greater than equal to 0 plus 9. So this expression is always greater than equal to 9. But I'm taking the square root. So if I'm taking the square root, this expression, this inside one expression is always greater than equal to 9. So its square root will always be greater than equal to 3. So I hope you have gotten it. Its minimum value. What are we asked? All the possible values of this expression. So this expression, let's say, is equal to y for a while. So I'll say y will always be greater than 3. Greater than 3 means what? Included 3, because this can be 3. When will it be 3? So when x is 1, this becomes 0. And with 0, this is 9. Under root 9 means what? 3. And then from 3 to all the greater values, that is 3 to infinity it takes. All the participants understood that. Can I move ahead from here? Everybody with me on this? Now, then, when we talk about the next question, I hope with this, you will try this question by yourself. This question I'm giving you as a homework question. I hope you'll do it. Now, with that, and of course, once you do it at home, do write your answer in the comment box that what did you get the answer. Not in this live chat, in the comment of this video. Do write that answer. Now, from here, when I go ahead, what do we see? The next category of questions. That's again a very interesting one. I'll solve any of these, and the second one I'll give as a homework. Can we solve the second one? Let's solve this one. This one I'm giving you as a homework. Now this is based on reciprocal, right? Here, pay attention to this part. X square minus x minus 1. Can you help me with the range of this expression? Again, converting it into a perfect square. So if I could simply try on or work on x square minus x plus 1, there are three methods. One of the methods is converting it into a perfect square. Second method, application of derivatives. First derivative, critical points. Second derivative test, maxima or minima. Third method, at minus b by 2a, comma minus d by 4a, you find either its minima or maxima, depending on the coefficient of the x square. So here, if I pay attention, coefficient of x square is positive, upward facing parabola, so it will have a substantial minima. To infinity, its range it will be. I hope you got that. Or if you are not understanding it, I'll use another method. Let's call it f of x for a while. Can we use application of derivatives, which you must have studied in physics as well? So what can you say about f dash x? I hope you can see f dash x is going to be 2x minus 1. So with that, you put it equal to 0 to find the critical points, and x is going to be 1 by 2. Everybody understood that? So this is the point where its minima will lie, because it is going to be an upward facing parabola. So if I find its value at 1 by 2, that value will be its minimum value. So if I replace x by 1 by 2, that will be the minimum value. So f of 1 by 2 will be minimum of f of x, which will be what? 1 by 2 square, that is 1 by 4, minus 1 by 2 minus 1. I hope you are comfortably understanding whatever I'm doing. So with that, can I write it as 2 by 4? And this has 4 by 4. So 4, 4, 4. This is minus 2, minus 4, minus 6, plus 1 is minus 5. So this value turns out to be minus 5 by 4. So the minimum value of this expression is minus 5 by 4. What does it mean? It means that x square minus x minus 1 will always be greater than equal to minus 5 by 4, and it will always go till infinity. Now go back to the 2 slides back. Did we not discuss how to take the reciprocal of this? I hope you remember. Let's call it all a variable. Let's say y. So if I take its reciprocal, I hope we know how to do it. With reciprocal, the sign changes. So if I talk about 1 upon x square minus x minus 1, I hope everybody is understanding this comfortably. This is from a negative value to infinity. So in between, I'll be facing 0. I hope you're understanding. First of all, it is taking all the positive values. It is taking all the positive values, because from minus 5 by 4 to infinity, that means 0 to infinity is already there. So if you take the reciprocal of all the values from 0 to infinity, that means the reciprocal will also be from 0 to infinity. I hope you're getting it. Or if you're not getting it, I can say it like this, that although x square minus x minus 1 could be 0, there will be roots of this equation where this expression will become 0. But when I'm talking about its reciprocal, there I cannot afford to keep x square minus x minus 1 to be 0. So can I split into two parts, where I'm splitting it into two parts? Which two parts, students? I'm saying minus 5 by 4 to 0, or this x square minus x minus 1 from 0 to infinity. I'm not putting it equal to 0, because I'm going to take the reciprocal here. Now pay attention to this part. When I take the reciprocal, so all the values from minus 5 by 4 to 0, all the values from minus 5 by 4 to 0, I hope you know, again, when the reciprocal is taken, the sign changes. That's it. So here I'll say that 1 by, this expression I'm calling as, let's say for a while, y. So this y will lie between what? If this expression is greater than minus 5 by 4, so its reciprocal will be less than minus 4 by 5. Its reciprocal will be less than minus 4 by 5. Since it is included, this will also be included. Less than minus 4 by 5 means what? It will be coming from minus infinity, as we have just discussed in the previous slide. Everybody got that? Or, I hope you remember union. If I take the reciprocal here, 1 by 0 infinity, 1 by infinity 0, so this will again lie between 0 to infinity. So the another domain of this expression will be from 0 to infinity, and the other range of this expression will be from 0 to infinity. Everybody got that, or shall I repeat this part? Just give me a quick confirmation on this. Are you understanding how are we dealing with the range of reciprocal of an expression? I worked out the range of this expression, but when we took the reciprocal here, how did I write this part? Did you understand it? If you did not, do write in the comment box. I'll definitely re-explain if you did not get any part from here. Now let's talk about the wavy curve method. What is that? I'll explain all of this with that conclusion only. But when I talk about this part, I'll begin with this. Let's say I am given an expression which is given like this: x minus 2 into x minus 3, and it is said to be greater than or equal to 0. Now what does wavy curve method say? It says that here plot these numbers 2 and 3 on the number scale and begin with the right hand side, put a plus sign here, a minus sign here, and a plus sign here. Why am I saying so? Because this quadratic is going to be an upward facing parabola where between 2 to 3 it will be negative, after 3 it will be positive, before 2 it will be negative. Which means if somebody says that it should be greater than or equal to 0, which means it will be greater than or equal to 0, which means positive or 0 between minus infinity to 2 or between 3 to infinity. Which means for this inequation, the solution will be, sir, minus infinity to 2 or 3 to infinity. Did you get that, or shall I re-explain this part? All the participants, everybody with me on this? Let me give you more clarity on that. Here, let's say if I'm given another quadratic, which is already there in its splitted form, x minus 5 into, let's say, x plus 4 for a y is less than 0. So this time I want it to be kept negative. Again, simply this, plot these points here. I hope minus 4 and plus 5. So this will be minus 4 plus 5. What you do is plus, minus, plus. But this time I want it to be negative. So it will be negative between minus 4 to 5. Will I include minus 4 and 5? No, because equality is not given over there. So first of all, will you remember this as a direct result now? What do I mean by a direct result? Let's say I'm given x minus alpha into x minus beta. I'm given an expression which is x minus alpha into x minus beta, where alpha is less than beta. Where alpha is less than beta. So technically, I can clearly see this is going to be a parabola which has two roots, alpha and beta, upward facing parabola. So if somebody asks you, where will fx be positive? So we know fx will be positive before alpha and after beta, before the smaller root and after the greater root. So there I can always say if fx is said to be positive, it will be true for all. This sign represents for all. So fx will be positive for all values of x which are either less than alpha or greater than beta. Are you understanding this? How am I writing this expression? All the participants, everybody with me on this? From here, let's say, had somebody asked you, if fx is needed to be negative, where will it be negative? I hope you remember, between alpha and beta, it is below the x-axis. So here, between alpha and beta, it is negative. Which means what? fx will be negative for all values of x which belongs to. This sign, I hope you remember, we have already discussed, represents belongs to. So where x belongs to the values between alpha and beta. So here x belongs to all the values between alpha and beta. So instead of applying wavy curve time and again like this for a quadratic, can you not directly write the result? The only mistake students commit here is this part, where if this x minus alpha and x minus beta, here if x has a negative coefficient. Here the only understandable thing is that I am taking the coefficient of x to be positive. If the coefficient of x is negative, then you take that negative sign common first. Because if the coefficient of x square is negative, instead of upward facing parabola, it will be a downward facing parabola. All of this will be cleared when I discuss wavy curve method. I'm coming to that. But before I come to that, let us draw conclusions on this part as well. Let's say x square is said to be greater than 9. Then you can directly write the result that, sir, if x square is greater than or equal to 9, then I'll explain the logical part. X square is greater than or equal to 3 square, which means x square minus 3 square is greater than or equal to 0, which means it can be written as x plus 3 into x minus 3 to be greater than or equal to 0. And I hope you remember, here the roots are minus 3 and 3. Greater than or equal to 0 means what? Lesser than the smaller root, greater than the bigger root. So here x will be either less than minus 3 or greater than 3. That's the solution. From here, you can directly remember this as a result, that if I say that x square is greater than or equal to a square, then don't do all of this. Now remember this as a direct result, that, sir, here x will be either less than minus a or x will be greater than plus a. Will you remember this as a result? From here, let's talk about one more conclusion. Let's say if I say that x square is less than equal to 25, or let's say x square is less than 25, then can I say x square is less than 5 square, which means x square minus 5 square is less than 0, which means I can write it as x plus 5 into x minus 5 to be negative. Again, if I have x plus 5 and x minus 5 to be negative, as per Wavekar method, I know minus 5 and 5, two roots, and if it is negative, lies between the roots. I hope you know that. So here I'll be saying that x will be from minus 5 to 5. Can I include minus 5 and 5? No, because I'm not including it to be 0, which means I could have written it like this, that x lies between minus 5 and 5. What does it mean? It means that a direct conclusion you should remember. What is that direct conclusion? That if somebody says that x square is less than a square, if x square is less than a square, then without even doing all of this, you should directly write the result that x will be lying between minus a to a. Everybody got this, or shall I repeat this explanation, students? All the participants with me, are you all there? From here, let us talk about modulus as well, because it is again a very interesting concept. Modulus means what? Let's say if somebody says mod x is less than 3. What does it mean first of all? Modulus means distance. So mod x means I can write it as mod x minus 0 to be less than 3. So distance of x from 0 should be 3. This means that I'm looking for all the values of x whose mod is less than 3. So I hope if you plot it on the number scale, you will start seeing it that, sir, if I take all the numbers from 3, 0 to 3, or from 0 to minus 3, their modulus will always be less than 3. Because see, 2.5 minus 2.5, 1.5 minus 1.7, they'll have their mods to be less than 3. So whenever somebody says mod x is less than 3, then you should not hesitate in saying that, sir, x will be from minus 3 to 3. You can draw this direct conclusion, which means the generalization here is that if somebody says that mod x is less than equal to a, what will you say? That, sir, x will lie between minus a to a. Will you remember that result, all the participants? From here, one more conclusion can be drawn. What is that? Let's say if somebody says that, sir, mod x is greater than 7. What does it mean? It means I'm looking for all those x whose modulus is greater than 7. Now, can you not imagine that, sir, if you take all the numbers which are greater than 7 or all the numbers which are less than minus 7, I hope you can imagine this. Let's say minus 8, minus 9, minus 10, their modulus is greater than 7. 8, 9, 10, 11, 12, their modulus is greater than 7. So here, if somebody says mod x should be greater than 7, what does it mean? It means x will be either less than minus 7 or x will be greater than 7. Are you not able to relate modulus with square? The same phenomena we have seen when x square greater than a square was given. We said x will be less than minus a or x will be greater than a. And the same phenomena we have seen when x square less than a square was needed to be taken. We said x will be lying between minus a to a. So modulus and square behave similarly. Will you remember that? All the participants who are understanding it, clearly give me a quick response. Everybody got this? Can I move ahead from here? Now, the next conclusion, if I could draw from here, is this particular Wavekar method based question will solve, but everybody got this part? All the participants? I hope there is no confusion on that. Everybody with me on this? So generalization, if I wish to write, let's say mod x is greater than a. Mod x is greater than a. Where understand this a is a positive number. A should be a positive number. So I'll directly write the answer as that, sir, mod x will be either less than a or, sorry, x will be either less than a or x will be greater than a. Two things I'm going to ask and try and answer this. What will be your answer if I say mod x is less than minus 3? And second question is, what will be your answer if I say mod x is greater than minus 3? What are your answers in these two cases? What will be your answer? I hope you're realizing what is the meaning of mod x. It means a non-negative number, the absolute value, the numerical value, which means this value will always be greater than equal to 0. But sir, you want it to be negative. Is it not a contradiction where I say that this should be greater than equal to 0 and this says it should be less than minus 3? Can it ever happen? You take any number and we know its modulus. Can it be negative or can it be less than minus 3? Never. So here solution will be phi. Phi means nothing, nil, void. This is not 0. It is phi, nothing. So no real value of x could satisfy it. Everybody got this? What will be your answer if mod x is greater than minus 3 is set? What will your answer in that case? I hope everybody is realizing, sir, mod x is always greater than equal to 0 and you want it to be greater than minus 3. So, sir, modulus of a number is always non-negative. It is either 0 or positive. And you want it to be greater than minus 3, which means you want it to be greater than minus 3 means what? Either 0 or negative, or minus 2, minus 1 as well. Minus 2, minus 1 it will never be, but it will always be greater than minus 3. Because modulus of all the real numbers lies from 0 to infinity. So will you not say that, sir, here the solution will be all the real numbers? Because all the real numbers, modulus is greater than 0. So eventually it is bound to be greater than minus 3. If a number is greater than 0 or equal to 0, it is definitely greater than minus 3. Did you get that part, all the participants? Now let's get clarity on wavy curve method. What is that? Let's take an example. Let's say here there are numbers like 2 minus x to the power 3. Then you have x plus 7 to the power 4. Then you have, let's say, 3x minus 4 to the power 2. And this I want to be greater than or equal to 0. First of all, to apply wavy curve method, the best advice I can give to you all is that ensure the coefficient of the x is plus 1. That will simplify your problem. I repeat, while you're applying the wavy curve method, ensure that the coefficient of x is plus 1. I can see there is a problem that coefficient of x is minus 1. Here coefficient of x is 1, which is great, but here also coefficient of x is 3. So first of all, I'll try to do some adjustment. So if I take minus sign common here, it will be x minus 2 cube, great. This is as it is x plus 7 to the power 4. And if I take 3 common from here, it will be x minus 4 by 3 whole square. What did I take common? 3. So it will be minus 3 because minus 3. And this is greater than or equal to 0. Everybody with me on this so far? I hope there is no confusion. What are we discussing here now? We are discussing the wavy curve method. All the participants with me? Now, from here, if I divide both the sides by minus 3, what happens then? If I'm dividing both the sides by minus 3, I hope you remember, negative number, which means sign of the inequality changes, which means what? This minus 3 when introduces, this greater than equal to becomes less than equal to. Give me a quick update on this. Are you all with me on this? Now from here, when I solve it further, what do I get next? All you need to do is draw the number scale. Plot the points where these factors become 0. So sir, 2, minus 7 and 4 by 3. So I'll have minus 7 here. Then I'll have 4 by 3 here. And 2 is greater than 4 by 3. So it will be on the right hand side of this. I hope this is easy and understandable. From here, what I say next is that of course it is minus infinity and that's your plus infinity. This region 2 to infinity is always going to be positive. What does it mean? I am claiming that if you take any number greater than 2, you take any number greater than 2, put it here, it will be, put it here in this part, it will be positive. Are you understanding it? Everybody with me on this? I hope there is no confusion on that part. Everybody with me on this? I repeat, 2, any number greater than 2, 3, 4, 5, you try any number and put it here, you'll find it to be positive. Now look at this 2. Where did you get this 2 from? Sir, we got this 2 from this. Look at this power of this factor. Sir, the power of this factor is 3. Can you tell me whether it is odd or even? Sir, it is odd. If the power of that factor is odd, the sign changes. Brilliant, Sachin. That's perfect. Thank you so much for highlighting it. So if it was plus, this region will be negative. So from 4 by 3 to 2, it will be negative. Perfect. Brilliant sign, Sachin. Good observation. Now, talk about this 4 by 3. Where did you get this 4 by 3 from? Sir, we got this 4 by 3 from this factor. Look at the power of this factor. The power is here even. The power is here even. So when the power is even, the sign doesn't change, which means if it was negative, this will be negative here as well. Everybody got this? Everybody with me on this? Now, let's look at this minus 7. I got this minus 7 from this factor. The power of this factor is what? Even. So if this 4 is again even, which means sign doesn't change. Had it been odd, sign would have changes. It would have been plus. But since it is even, the sign wouldn't change and it will still remain negative. Everybody got this? I hope you're with me on this. Although equal to 0 is also there, so I will not hesitate in including minus 7, 4 by 3 and 2 in my answers. Because at these values, it is becoming 0 and those points I got to include, got to keep in my answer. Now from here, when I go ahead with my final conclusion, I will say, sir, I want this expression to be negative or 0. So when do I see it to be negative? We see it to be negative here, here, and here. And where do we see it to be 0? Sir, at minus 7, 4 by 3 and 2. Will you not say? You will write your answer as, sir, minus infinity to minus 7, 4 by 3, 2. So ultimately 2. I hope this satisfies it. Because if I take any value from minus infinity to, it will be, this expression will be negative. So the answer to this question, where this expression was supposed to be kept positive, will be between minus infinity to 2. You take any value between minus infinity to 2, you put it here, this inequality, this inequation will be satisfied. Everybody understood this? Everybody got this? Can I move ahead from here? All the participants. Now from here, when I go ahead, this is a standard simple question. Yes, Sachin, that's brilliant. I hope you can try this question by yourself now. This is what I'm treating as a homework question. Try this based on the same approach you were told, and then do write its answer in the comment box. Not in this live chat, but in the comment of this video. I hope after the session, you will be solving this and writing it. And I hope you're aware that this entire PDF of these identities and all will be shared with you. All you need to do is check the description. Everything is mentioned there. Now from here, when we go ahead, what do we see next? How do we solve this one? As we have been constantly pitching or mentioning, don't do the cross multiplication. Do you remember this? While discussing inequalities, I have been constantly telling you that you don't cross multiply them. And then if we cannot cross multiply, what do we do? I hope you remember, you shift it on the left hand side. So what happens here is x minus 2 by x plus 2 minus 2x minus 3 upon 4x minus 1. That is what we can do, because you are shifting it on the left hand side means what? You are subtracting this expression from both the sides, and you can do that. And with inequalities, that is doable. So with that, when I go ahead, I hope you are seeing, now I can take the LCM. So it will be x minus 2, 4x minus 1 minus 2x minus 3, x plus 2. And in the denominator, it will be x plus 2, 4x minus 1 greater than 0. So I got to simplify the numerator first. So let me work on the numerator. It will be 4x into x. That is what? 4x square. Then it will be minus 8x minus x. So that will be minus 9x. And there you have plus 2. Correct me if I'm wrong in terms of calculation. 4x square minus 8x minus x minus 9x and plus 2. There it will be 2x square. But with this, it will be minus 2x square. Then it will be minus 3x plus 4x. I hope you are there. Plus 4x minus 3x is x, but because of this, it will be minus x. And then you have minus 3 into 2, that is minus 6. And because of this, it will be plus 6. Everybody with me on this? And this divided by x plus 2 times 4x minus 1 should be kept positive. Everybody with me on this? All the participants? Yes, take the terms on one side, sir. Brilliant, Sachin. That's a perfect suggestion. I was hoping or expecting that somebody would respond. Great. Now from here, all I'll do is simplify the numerator. 4x square, 2x square gives you 2x square minus 9x minus x, that is minus 10x. And 6 plus 2 is 8. Even if I take 2 common, it will be x square minus 5x plus 4. So it will be x square minus 5x plus 4. I hope you're understanding. When I take 2 common, that is plus 2. So if I divide both these sides by plus 2, the sign wouldn't change. So that 2 vanishes. In the denominator, it will be x plus 2. From this 4x minus 1, if I take 4 common, it will be x minus 1 by 4. Although you can keep it as 4x minus 1 also, but if you get confused, you can write it like this, greater than 0. Now I hope splitting the middle term, I can split this minus 5x as minus 4x minus 1. So it becomes what? Minus 4x minus x plus 4. I hope you're getting it very clearly. So one of the factors is going to be x minus 4. One of the factors is going to be x minus 4. The other factor will be x minus 1, because x minus 4, then you make it x minus 4 by taking minus 1 common. So it will be x minus 1. Then it will be x plus 2, and it will be x minus 1 by 4 greater than 0. Now can you not apply wavy curve? I hope you are comfortable with that. So when I now apply wavy curve, I hope it's a matter of plotting these points. So 4 points are going to be there. Let's look at them. 4, 1, 1 by 4 and minus 2. So minus 2 is the least. Then you have 1 by 4. Then you have 1 and then you have 4. Minus 2, 1 by 4, 1 and 4. I hope all the factors are having odd powers. All the factors are having odd powers. So alternatively plus minus plus minus. So it becomes with plus minus plus minus plus. What do we want? Sir, we want this expression to be positive. So where do we see it to be positive? here, here, and here. Of course, this is your minus infinity. That's your plus infinity. With that, I hope we can directly write the final answer as that x belongs to minus infinity to minus 2 union 1 by 4 to 1 union 4 to infinity. Give me a quick update on this. Everybody understood that result? Are you all there? Listening, watching, and understanding this? Clearly got this? Everybody? Now, from here, when I go ahead, let's see what unfolds next. This is exactly based on what we have just discussed. So I'm giving you it as a homework. Homework means this is exactly what we have discussed. You need to deal with the odd and even powers. Take care of this, that the coefficient of x is 1 so that you don't face any problems with the values of x. And with that, you can write the final answer within seconds. This is all about modulus. We have simply discussed it. Something crucial which you got to remember is that x square and mod x square are replaceable. That means in question, if you need it, you can replace x square by mod x square, and on quadratic based questions, they ask you to do it. Modulus of x or minus x is always same, and modulus can be splitted over product or division, but it cannot be splitted over addition or subtraction. This is something I am hoping that you all are aware of. This is also we have discussed a lot many times. I hope you all are clearly aware of it, that x squares under root is mod x. I hope you do remember it. For example, this 1 minus root 2 squares under root will not be 1 minus root 2, because if it is 1 minus root 2, it is negative. So I supposed to put modulus over it, and when modulus is removed, it becomes root 2 minus 1, the non-negative value. Getting it, everyone? All the participants? Now from here, a square less than b square, as we have just discussed, it will give me mod a less than mod b. I hope you got this part. From here, when we go ahead with this, now let's talk about this. Let's say x lies between minus 3 to 1. So this behaves same as x square. I hope you remember that. We have already discussed. So imagine x takes all the values from minus 3 to 1. And I'm putting modulus over all those values. What range will I get? So imagine x is taking all the values from minus 3 to 1. So there is minus 3, then somewhere you will have 0, then you have 1. So if you put a modulus over all of them, you will of course get 0 in between. So I hope you understand, when x is from minus 3 to 1, modulus of x will be attaining its minimum value 0. Now, modulus of 1 will be 1, modulus of minus 3 will be 3. So its maximum value will be 3. But will I include an equality here? Yes, because minus 3 is included. So mod of minus 3 will also be included. Did you get that, or shall I re-explain this? Everybody with me on this? Or shall I re-explain this part, all the participants? Now, let's take one more example so that you get more clarity here. We need to put our comment on mod of x minus 2, where x is from minus 5 to 7. So first of all, if x is from minus 5 to 7, if I subtract 2 on all the three sides, it doesn't affect our inequality, because we can add or subtract a same number on all the sides of an inequality. With that, this is minus 7, this is x minus 2, and this is 5. Now, if I put a modulus over here, I hope you can plot it on the number scale to get more clarity, although you don't have to, but if you wish to have more clarity, I hope you're understanding. If you are putting a mod here, which means you're taking modulus of all the values between minus 7 and 5. So when you take the modulus of all the values between minus 7 and 5, I hope you're realizing that the least value here is going to be mod of 0, which is going to be 0. And I'll attain 0 because between minus 7 and 5, 0 lies, which means I'll have the 0, which means I'll use equality here. And now if I put modulus on all these values or on all these values, the maximum from here I'll get plus 5. The maximum from here I'll get will be plus 7. So of course, the value here will be 7, which I am not supposed to include, because here 7 is not, minus 7 is not included. That's good, Sachin. That's brilliant. Are all the participants understanding these questions, their solutions? Now this question I'm giving you as a homework, because this is clearly based on what we have just studied or discussed. So once you watch this or solve this, do post your answer in the comment box, not in this live chat, in the comment of your video. How do we solve this particular one? I hope you are paying attention to this part. X is given, you can find 2x, you can subtract 7 on all the three sides, and then modulus. You already know how to take it. Everybody with me on this? Will you do it by yourself now? Yeah. Moving ahead from here, what do we see next? Yes, this is what we need to prove. How can we prove it? Can you help me? X square plus 2x plus 1. What is it? Sir, it is a square plus b square plus 2ab. So it is x plus 1 whole square inside an under root. What is it? A square plus b square minus 2ab. So it is x minus 1 whole square inside an under root. Now I hope you do remember, then when under root cancels this square, modulus comes into picture. So with that, I'll have x plus 1 here, and with that, I'll have x minus 1 from here. Everybody got this? Everybody got this? That's good, Sumit. Now from here, all I'm going to do is pay attention to this part, everyone. I'll have the points where I'll be splitting this. So minus 1 and then 1. I'll divide this. I'll create its piecewise definition. So I'll say, sir, when x is less than minus 1, sir, when x is from minus 1 to 1, and the third part where x is greater than 1. In these three domains, I'll divide it because here the modulus expression changes its sign before minus 1 and after minus 1. Here it changes its sign before 1 and after 1. So I'll be splitting into three zones like this. Everybody got this? Now let's talk about this first result. Which result, student? When x is less than minus 1. So sir, when x is less than minus 1, it will be negative. This will also be negative. So when the value inside the modulus sign is negative, it opens with a negative sign. I hope you do remember, mod x is defined like either x or minus x. So it is x whenever x is positive or non-negative, or it is minus x whenever x is negative. I hope you do get this. If you are not getting it, take any value less than minus 1, put it here and put it here. You will see it to be negative. And if it's turning out to be negative, to remove the modulus sign, I'm supposed to put a negative sign so that it becomes positive. I hope you're getting it. So with that, when x is less than minus 1, this will be negative. This will also be negative, which means this when opened opens with a negative sign. So minus of x plus 1, which is minus x minus 1. And when this opens with the negative sign, so negative of negative will make it positive and it will become x minus 1. Everybody got this? Everybody? This minus x cancels this x, and minus 1 becomes what? Minus 2. So it will be minus 2. I hope there is no confusion on that. Now let's talk about the next result. X is between minus 1 and 1. Here, let me try a value 0. So when I put a 0 here, it is plus 1, which means it will be positive. When I put a 0 here, it will be minus 1. That means it is negative. So if this expression is positive between minus 1 and 1, the modulus will removed as it is. So this will be x plus 1 minus. This part x minus 1 is negative between minus 1 and 1. So in that case, it will open with a negative sign. So that negative with this negative will make it positive. So it will be again x minus 1. So this minus 1 cancels and x plus x becomes what? 2x. Everybody got this? Can I move ahead from here? Third conclusion, when x is greater than 1. So to prove these equations, can't we take some values of x? Yes, in boards you can. No, in boards you cannot. In boards you'll have to apply the step-by-step solution. Although we are not teaching you for boards, I am trying to teach you this concept of modulus. That when square root of a square is taken, you introduce modulus. And how do we remove modulus to create the piecewise definition? That's the intent here. That's why we have deliberately kept this question. Although it is never going to appear in JEE, but this is how you build the basics. This is how you build the foundation. This is how you work upon your basics, which might not have gotten developed in 11th standard or so far till 11th standard. That's why we are bringing you this bridge course between 11th and 12th before your 12th, after your 11th, of course. Now here, if I talk about the third part, what do I see? X is greater than 1, which means this will be positive, this will be positive. So if both of them are positive, modulus will get removed like that only. So this becomes x plus 1 minus of x minus 1, which is minus x plus 1. So x and x are cancelled. You're left with 1 plus 1, which is 2. And I think it matches with this. Everybody understood that result. Can we move ahead from here? Now, when I go ahead from here, what I see is this particular one. Now, how do we solve this one? Sir, the problem here is it has a modulus sign here. And it has some non-modulus, terms with non-modulus as well. And there is this one as well. How do we get rid of it, or how do we simplify this? Let's pay attention to this part. By the time I am solving it on the screen, you can also solve it along with me. First of all, what I'll do is I'll shift this one on the left hand side. So what will I have here? I'll have x plus 3 plus x divided by x plus 2 minus 1 to be positive. X plus 2 goes here. So it becomes x plus 3 is modulus plus x minus 2 divided by x plus 2. This needs to be kept positive. Everybody listening and understanding this, all the participants. From here, I hope you can see this very clearly that this x and this x are cancelled. So what are we now left with? We are left with mod of x plus 3 minus 2 divided by x plus 2 to be positive. Give me a quick update on this. Everybody with me on this? Mod of x plus 3 minus 2 divided by x plus 2 to be positive. Yes, go ahead with that. Now from here, when I move ahead from here, I hope you're understanding. I got to split it because here you cannot use the wavy curve because here you have this expression in terms of modulus. So first of all, let us ensure that how do we divide it into ranges. So I'll be solving it into two parts. What is that query in the last question? Do post it. So I'll divide it into two parts. Which two parts? In the first portion, I remove this modulus sign. So to remove this modulus sign, I have two choices. Either x is less than minus 3 or either x is greater than equal to 3. So the first case I'm creating where x is less than minus 3. Or the second case where x is greater than equal to 3. Or means whatever answer I finally get, I'll use the union. I'll get an answer from here. I'll get an answer from here. I'll put in union means or. Can I move ahead from here? Now, if x is less than minus 3, which means this x plus 3 will be negative. So this modulus opens with a negative sign. So it will be minus x minus 3 minus 2 divided by x plus 2 to be positive. From here, if I take negative sign common here, it will be x plus 5 in the numerator. And that negative sign will change this sign. So here it will be x plus 5 divided by x plus 2 to be negative. I hope everybody is listening that. I got it. Kaka, Diya, Kirtan. Do post your query or concern. I'll definitely resolve it. Post your query. Post your concern. I'll resolve it. Now from here, this clearly is like that wavy curve method. Roots are going to be minus 2 and minus 5. It is needed to be negative. So between the roots, it happens between minus 5 and minus 2. So here I'll say that x lies between minus 5 and minus 2. But we had already begun with x being less than minus 3. And it says that, sir, x should be between minus 5 and minus 2. So I'll be taking the intersection of these two. So thus intersection of these two, I hope you're able to visualize. It says less than minus 2. It says less than minus 3. So minus 3 is more closer because minus 2 to minus 3, these values are not there here. So the intersection of this and this will give me that, sir, here x will lie between what? Minus 5 to minus 3. But that's the solution of this first part. Union, solution of this part. Everybody with me on this? So, sir, when x is greater than equal to 3, this expression will be positive, which means it will open as it is. So, it will be x plus 3 minus 2 divided by x plus 2 divided by x plus 2 to be positive. And 3 minus 2 is clearly plus 1. So, it becomes what? Plus 1. So, it is x plus 1. Again, plus 1 plus 2. So, roots are going to be minus 2 minus 1. But it is positive. So if this is positive, happens before the smaller root or after the greater root. I hope you remember that discussion we had. So smaller root is minus 2, greater root is minus 1. So the solution here will be x should be less than minus 2 or greater than, I hope you're discussing it, understanding it, greater than minus 1. Everybody with me on this? But with this, I got to club this result as well. Sir, you are saying that x should be less than minus 2, but this says x should be greater than 3. So this does not fulfill it because intersection is needed to be taken where both of them are getting satisfied. So this and this don't match. But this said this can also be there. So x is greater than minus 1, x is greater than 3. So if a value of x is taken which is greater than 3, it will eventually be greater than minus 1 as well. So if I take intersection of this and this gives you that x should be greater than 3. X should be greater than 3. So here the solution will be x should be greater than equal to 3 because equality is also there. So the final solution to this question here will be this. Just give me a quick update on this. All the participants who are watching it right now, did you all get this? Did you all understand this explanation? Can I move ahead from here, all the participants? Everybody with me on this? From here, when we solve this, inequalities involving modulus, we have already done that part. This is exactly what I am going to now discuss, although we have given a clarity on that. We did discuss that mod of x is less than a. then x lies between minus a to a. Do you remember that? So if I remove the modulus sign, I'll say 3x minus 2 will lie between minus 1 by 2 to 1 by 2. Do you all remember that? So if I add 2 on both these sides, it will be minus 1 by 2 plus 2 less than equal to 3x less than equal to 1 by 2 plus 2. So here it will be 2 minus 1 by 2, that is 3 by 2. I hope you're understanding it. So 3 by 2 less than equal to 3x, and this is 5 by 2. If I divide both the sides, all the three sides by 3, it will be 1 by 2 less than equal to x, and it will be 5 by 6. That's your final answer. Was it not easy and simple? Are you not gaining confidence with inequalities based questions? Now, when you solve inequations, I hope you will comfortably handle modulus, square, reciprocal, and all of that. Everybody with me on this? Can I move ahead from here? Let's solve this one. This is again a more interesting one here. First of all, when you remove the outer modulus, we'll use the outside in approach. So when I remove the outer modulus, what happens here is that when, I hope you remember, we did discuss that mod x is greater than a, then we did discuss that x should be less than minus a or greater than a. I hope you do remember this as a result we discussed. Do you all remember that? So if I apply that logic here, what do I get? So if modulus, the outer modulus is removed, then mod x minus 1 minus 5 will be either less than minus a, which is minus 2, or means ultimately I'll use the union between this answer and that answer. And here I get mod of x minus 1 minus 5 should be greater than equal to 2, which is a. Everybody with me on this? Now from here, if I push this minus 5 on the other side, so minus 5 when added to this minus 2 makes it what? Plus 3. So it becomes plus 3. Similarly here, when minus 5 goes to the other side, minus 5 makes it plus 7. Everybody with me on this? Then again, when I delve further, I hope you remember one more conclusion we have already discussed. What was that? Sir, if mod x is less than a, then we do remember x lies between minus a to a. I hope you do remember this result as well. So if I apply this, mod of x minus 1 is less than equal to 3, which means x minus 1 will lie between minus 3 and 3, which means if I add 1 on all the three sides, it will be minus 2, 2, 4. That's the first conclusion. And here, when mod of a number is greater than equal to a, I hope that logic again comes into picture. X minus 1 will either be less than minus 7 or x minus 1 will be greater than plus 7. So here we conclude x is less than equal to minus 7 plus 1, which is minus 6, or x is greater than equal to 8. I hope there is no confusion on that. Now I am supposed to put a union here. A union here. So union means, pay attention to this part. Pay attention to this part. This says minus 2 to 4. This says less than minus 6. That says greater than 8. I hope you can clearly see, even if I make you understand this by plotting these numbers on the number scale here, you'll be having minus 6. So this is minus 6. So it says x can be less than equal to minus 6. This says that, sir, x can be greater than equal to plus 8. So that is what this part is suggesting. But greater than minus 6 is minus 2 and less than 8 is 4. So this says that x can be from minus 2 to 4. X can be from minus 2 to 4. And if I take the union of this part and this part, no, it will not be from minus 6 to 8, Sachin. I hope you're understanding. Union is what means I'll be saying, sir, my answer will be from minus infinity to minus 6. My answer will be from minus infinity to minus 6, or from minus 2 to 4, or from 8 to infinity. Everybody got this, or shall I re-explain this part? All the participants. Give me a quick update on this. How did I take the union? Sachin and all the participants. Everybody with me on this. Don't apologize. Just don't make that mistake again. Everybody got this. All the participants. With that, when I move ahead, what I see next is few more questions. No, we are done with our first discussion. This was your bridge course, session number 1 from mathematics, that when you pass 11th and move into 12th, and when you prepare for competitive exams, you should know the nuances, you should know the basics. So all the notes of this session will be given to you. Just check the description box there. Everything is mentioned. How can you get the or access the notes? And I hope you remember, when you prepare for competitive exams like IIT JEE, you got to have excellent basics, amazing foundation. Not just till 11th standard, but also till from the 1st to 10th standard as well. Not of only of 11th standard. And that's exactly what we are covering in this bridge course. So 3 more sessions are coming planned ahead of mathematics in this bridge course, of which first mathematics session we have conducted today. So I hope you must have learned and enjoyed a lot. With that, let's call it a day. Thank you so much. You have been a great audience. Take a good care of yourself. Good night, everyone.